the Faculty of Information Technology. I also express our gratitude to the University of Moratuwa for its institutional support and commitment to fostering a vibrant research culture. As we mark 10 years of excellence,
Good morning, Dean, Faculty of Information Technology, the Registrar, University of Moratuwa, the Dean, Faculty of Engineering, the Bursa, the Librarian, Director Research, heads of the departments, academic members, the Chair of the Organizing Committee of the conference, distinguished guests from India and other countries, my dear students, the paper presenters, it's my pleasure to be here for the inauguration of Icitr, the 10th Research Conference of the Faculty of Information Technology. This week is an important week for University of Moratuwa because it's named as the Research Week. We have several research activities, conferences during this period. For example, on Monday, we had the inauguration of the Research Week, mainly coordinated by the Faculty of Graduate Studies and the Conference of the Business Faculty. And yesterday, it was the inauguration of the Conference of the Faculty of Architecture, and today is the IT faculty, and tomorrow the symposium of the engineering faculty, and then on Monday the symposium of the Faculty of Medicine. So all 5 faculties are having either a conference or a symposium during this 7-day time period. Then also, as explained by the conference chair, co-chair, we are doing it during a difficult time period. We had to postpone it for 1 week due to the incremental weather and the resultant disaster. But in spite of that, the activities are going ahead. And then when we come to this conference, Icitr, as explained, it's the 10th conference. Having a conference for 10 consecutive years is not an easy task. And on that note, I should congratulate the deans, the former deans, and the organizing committees of this conference for continuing the conference for 10 long years during difficult times like COVID, having it online. And also the conference has improved both in terms of quantity, number of papers, number of paper presenters, but also in quality. I understand more than 150 papers have been received this year, and have selected about 60 plus papers, good quality papers for the conference. So in that sense, we understand both in terms of quantity and also in terms of quality, the conference has improved over the short span of the 10 years. I think it's special, I think, for the Faculty of IT, for the university, because It's a faculty which has cross-cutting activities or linkages with all the other activities of all the other faculties, because some of the departments or the faculties in other faculties, they might specialize on one particular area, might not have direct links or interactions with other departmental activities. But I understand during my recent interactions, this faculty, the activities are linked, and I think all other faculties, one way or the other, they have the activities related to information technology, teaching, research, dissemination of the knowledge, or for learning. So I would like to see in future probably more interactions at this conference also, where there are some people who are interested of using information technology and related developments in their domains. So they might also be able to come and talk those experiences here. And also the faculty has helped university in many ways during the last few years in the activities, in development of systems and other activities. So I appreciate the contributions made by the staff members of the faculty to the development of the university. And I think this today the staff and the students, especially the final year students, will have an opportunity to showcase what they have done during the last year to others, to the industry, and to the general public with the publications which will go online, I suppose. So finally, I would like to wish all the very best for the activities of this conference, and again congratulate the organizing committee and the staff for the hard work. Thank you very much.
Thank you very much, sir. We now warmly welcome Mr. B.H. Sudanta, Dean of the Faculty of Information Technology and General Chair at Icitr, to grace us with his thoughts on this occasion.
Very good morning to all of you. I think Professor Chandrasekhara, Deputy Vice Chancellor of the University of Moratuwa, Registrar, Dean Engineering, and Bursa, Librarian, Director Research, and all foreign delegates here, and our conference organizing committee, and the ITR Director, Dr. Tilaka, and my dear colleagues and all authors, ladies and gentlemen. And this is our 10th international conference, and all the time that we have mentioned our direct research also. But this is a research week of the University of Moratuwa. Okay. Now, with that research week, this is the faculty share of the research week. University of Moratuwa has organized this research week, but we know that anything we organize in the University of Moratuwa, we are doing it in very good manner. Because we are the #1 university in the Sri Lanka state university system. From different angles, we are #1 everywhere. That is what University of Moratuwa is. But each and every faculty, they are contributing to this one. All the faculties, they have identified their responsibilities and taken that huge responsibility on their shoulders, and they are doing this one very well. And everywhere in the country, the University of Moratuwa is there. We are doing that one in very good manner, and the quality we are maintaining is the highest quality we can see there. When it's come to the University of Moratuwa, then this is our faculty, this is our 10th conference here. Then understanding all these things from University of Moratuwa, all the staff members not only the academic staff, that non-academic staff and students, they have identified their responsibilities. From top to bottom, bottom to top, we are doing this one in very good manner. That's why University of Moratuwa is having this name. Now, when it comes to the Faculty of Information Technology, we also have identified what our responsibility is. And that's why we are maintaining this conference, and today we are celebrating our 10th international conference here. But once we said the 10th international conference, it's not an easy track, easy path we have gone through. 20 years back, we started this one as a very small symposium. Okay. From that end, we are, I think 10 years we had this research symposium. After that, I think Professor Subha Fernando became a research director in 2014, and during his the third year, she converted this one into international conference. Okay. Then in 2017, I was the research director. Then in my second year, with the support of Professor Sanat Jayawardena from Textile Engineering Department, with the support of Dr. Ferdhouse, we converted this conference into a IEEE sponsored conference. Since then, for 8 years, we have maintained this level of the conference, and all these years we have IEEE co-sponsorship there. From the beginning onwards, so from 2018 onwards up to 2025, we have maintained that all the acceptance ratio well below 40%, maintaining all the quality papers there. And in the initial conference also, it was 37% acceptance ratio. This year also we have 38% acceptance ratio. And with the support of all the reviewers, with their dedicated work and their responsible work, we maintain the quality papers there. Because of that we have received the scholarly excellence in this conference there. And I have to thank all the authors there that they are giving their papers here and sharing all their the valuable research work here with our conference there. Then, without taking much more time, I have to thank all the participants and all the organizing committee of the Faculty of Information Technology, that all the staff members, they are here, that they are working very hard to come to this level. And all the foreign participants coming here with their time and all these things, and since then that they are working with us, and many other universities, many other foreign countries, they are working with us since then. And thank you for all the foreign delegates here coming here. And not only here, that some of the keynote speakers, they are joining online with their countries. Thank you very much for them also. And I wish all the success during this 2 days period, and all the others, and you will have your network and all these things, and you will share your great work here. Thank you very much.
Thank you very much, sir, Mr. B.H. Sudhantha.
Now it's time to recognize our valuable sponsors whose contributions made this event a great success. Their commitment and their vision had transformed this event to a landmark of innovation and knowledge. So first of all, we have our technical co-sponsors, IEEE and IEEE Sri Lanka section. Next, we have our exclusive banking partner, Commercial Bank. And we have financial support partners. We have two of them, WSO2 and Synergy.
And with that, ladies and gentlemen, we are about to witness the first keynote address of the conference. Allow me to introduce you to our first keynote speaker, Professor Shan Sudhaharan. Professor Sudhaharan is a distinguished authority in artificial intelligence and computational research who has devoted more than 4 decades to advancing the frontiers of machine learning, big data analytics, and information technology. Currently serving as the Professor of Computer Science at the University of North Carolina at Greensboro, his scholarly contributions span from foundational work on wireless sensor networks to pioneering theories that are reshaping the landscape of intelligent computing. He is the author of the acclaimed textbook, Machine Learning Models and Algorithms, published by Springer, which is a resource that continues to guide researchers and practitioners globally. Professor Sudharan's recent work introduces frameworks including Colony of AI, Human Gradient AI, Negation-Based Explainable AI, and Theoretically Infinite Family of Feature Spaces. In his keynote address today, titled Nature-Inspired AI, Evolutionary Intelligence for the Big Data and ICT Era, Professor Sudharan will reveal how nature's evolutionary intelligence can revolutionize modern ICT systems. So, with that, we are profoundly honored to welcome Professor Shan Sudharan to share his keynote address.
It is an honor to be here remotely at ICITR 2025 conference and share this moment with all of you. I would also like to thank the organizing committee for put together a nice program and organize this conference. So I'm also grateful for the invitation to deliver this speech. So, and also thanks the audience for attending my keynote speech. Okay, so today my topic is nature-inspired AI. Let me move this. Yeah, so nature-inspired AI, evolutionary intelligence for the big data and ICT era. So I'm Professor Shan Sudharan, Department of Computer Science, University of North Carolina at Greensboro. So I want to emphasize the theme of the conference established by the organizing committee and the conference organizers, the advancing global connectivity through emerging information technology solutions. So my speech is organized accordingly. So how do we advance the global connectivity? Before that, what is actually the global connectivity? And also how we could use the emerging technology to solve the problems in the systems that make the global connectivity. So the idea behind that is to consider the ICT, which is information and communication technology. So that combines both information technology and the communication technology. But in this era, these systems, they have to deal with big data. So we have several problems in the big data. So my focus would be to identify the actual problem so how we could solve or address the problems and try to find solutions with respect to machine learning and artificial intelligence. So the agenda for this talk is divided into few topics. First, let me introduce what information and communication technology, and then there are big data issues coming into picture. So that is named here as a tuned condition. So that's that comes from the Latin word cuneus, which means that the wedge-like shape. So that coming from the three directions could give a problem in the ICT. And then in the solution space, we look into machine learning and artificial intelligence. And then the emerging technique called multi-agent AI systems. And then let's look at what is the future of ICT based on these AI frameworks. So in order to solve more complex problems, we look into evolutionary multi-agent AI system. But nature teaches us about the evolutionary processes. So I'm basically considering here and then discuss with you about how we could collaboratively use AI agents into this picture. So first of all, what is global connectivity? It's a common terminology. We can see globally, all of us should be connected. So the connecting people, and then how do we connect devices and the systems and how we can utilize them. At the same time, how can we enable communications and access to information is needed, but safety is also required. So altogether, how can we contribute to the advancement of modern digital world using ICT framework? So the three components are the information, communication, and technology. So information technology research is advancing, but however, the communication technology also required as a framework so that the information technology approaches can be deployed. So, but what is the key component that is flowing through this ICT framework is information. But can we make this information more intelligent? So such that we can create superhighway and then make the global connectivity more efficient. So in order to do that, there are three components we have to consider. So we have been looking into all these things. One is the systems, that basically ICT frameworks that has all the devices, IoT devices, the cameras and all sort of different systems in the ICT. And then when these ICT devices or the components communicate, they generate knowledge. So when they generate knowledge, and then they also develop intelligence like human, but we don't use them as we don't consider them as a living organism. So we just make them as just a fixed network. So therefore, how do we look into that? So that is the most important priority now to advance the ICT frameworks and then the application of AI. So I'm really thankful for the conference organizers to look into that because this is a very needed research at this time in the AI era, which is advancing global connectivity. How do we connect all of it? Connect. So, but the thing is, we have to use some of the emerging things, that mainly the artificial intelligence. So how do we revise or modify, conduct research in order to apply this AI technology into the ICT frameworks? So the emerging technology, sorry. Yeah, so the emerging technology means that how do we integrate the AI frameworks to make the ICT to evolve? So that's what we are going to look at today in this discussion. So in other words, that removing the fixed characteristics of the network and then make or consider as a logical framework, right? Imaginary framework that can give us a living organism behavior in the system. So we already in the AI, artificial intelligence era, along with multi-agent AI systems, so we can make use of these, the current research and then the advancements in technology to make the system evolution. So the whole idea is for this talk is the making the intelligence evolutionary rather than adaptive intelligence. So in order to do that, first you need to probably understand, you probably already knew about these things, but I think it's good to recollect this information such that we can connect the advancement or the future of ICT. So as you can see in this diagram that there are two things we can group, like low-level triplets, which is the components or the systems that we require, and then the high-level triplets. So the low-level triplets are considered the communication technology, and then the high-level triplets are considered the information. So it's the handshaking mechanism. So both of them are really required. But the whole goal here is not to go deeper into the communication technology, rather go deeper into information technology. So that's the direction that, because there are a lot of data available, so big data problems, so we really need to more focus on that direction. So the hardware, software, network, and telecommunications can be grouped into low-level triplets, and then the data information, that's the main goal, but the applications and services are also required, and then the people and procedures. Okay. So in order to do that, what is the actual problem? What is preventing from developing a sophisticated system is this called here is the Kuhn condition. But I introduced this terminology in 2016 for the purpose of bringing the cognitive process into the random forest, but by looking at the big data problem. Uh, but the idea behind that is actually the three components, that's the triplets, making all of these a big problem in the ICT. So one of them is an uncertainty and unpredictability and unstructured. So as we can see that if it is uncertainty or unpredictable, first one, let's take unpredictability, that when it pushes into the ICT environment, that actually creates more problem with the unstructured and uncertainty. So that causes the problem for ICT to break apart. Exactly the same. So they are interconnected. So this become another triplet. So this is the 3 U's or U cube. So ICT basically currently sitting on a vulnerable base, which is a wedge-like space that consists of uncertainty, unpredictability, and unstructured. So this complex problem is actually very difficult to solve by adaptive approaches. So we really need to have all, like a evolutionary approach. But I'll explain to you what that adaptive and the evolutionary means in a simple form in a few minutes. But that's what is required. But then nature basically teaches us how to evolve things, so that's what we are looking at it. So if you're interested in more knowing about the Kuhn condition, you can look at my paper here in the cognitive randomness paper. So slowly as moving forward, that these 3 are orthogonal vectors, okay? So that means they're independent. It's like a 3D axis, you put X, Y, and Z, but here we are talking about 3 U's, they're orthogonal to each other. So they are base vectors, okay? So from that base vectors, U1, U2, U3, and then a fraction of these combined together create a diversified problem. As you change alpha 1, alpha 2, alpha 3, there's a new problem always. So it's a mathematical projection for the transformation of this simple problem, and then a simple problem caused by individually by each variables, the orthogonal variables, but that creates the final ICT problem. Okay. So if you already looked at the big data problem, that's already been defined, so here in the past, originally it's defined by 3 V's, volume, velocity, and variety. But when we look at big data, we always think in terms of volume, but that's not the case. But volume, velocity, variety, they create these 3 components, uncertainty, unstructured, and predictable, and then create these the technology problems. So later on, I created a C3. The purpose of doing that is to do more research. So bringing some mathematical models into it, because it's very hard to do it with this velocity, variety, volume. So we create cardinality, continuity, and complexity. So that made the life easier to visualize the actual problems the hidden in the ICT environment. But not only in ICT environment, any environment you could bring or you can model it easily. Okay. So again, you could look at these references in that needed. So therefore, the goal of this conference is really beautiful, because it's actually bringing in many expertise into the one framework, such that we could work on them. So therefore, we have to rethink that ICT and the Kuhn condition. The Kuhn condition is like the 3 U's that we are talking about, because they lead to a big data problem, like scalability, heterogeneity, and all these different problems. So therefore, in this forum, because you are getting together and then going to work on this week in your university, so think about it. We need to ask the fundamental question. Okay, how do we advance ICT under the Kuhn condition using evolutionary AI, not just an AI, because you really need to have evolutionary AI, And then so that the entire society, human society, and even a technology frameworks can benefit and then move forward. So what do we need to do to achieve that? So I'm actually presenting few ideas which already been published or under development. So you could basically look into the new directions research in these areas. So this conference provides you a forum so that you could discuss. So that's the whole idea of any forum. So you really ask one question and then go deeper into it and collaborate, and then you create better solutions that entire world can benefit. So the first phrase is advancing global connectivity, right? The other one is an emerging technology, it's a solution space. So this advancing global connectivity going to reshape this problem. So to advance global connectivity, first you really need to understand what is the internal mechanism and external mechanism, along with, of course, standardization. But this talk is not spending time on the standardization, but there are a lot of standardization bodies there, so you need to look at it. But this is more focused on the IT research. So I'm going to focus on more on the research directions that you could take. So to go deeper into it, I mentioned this is the low-level framework, and then hardware, software. You can think about some of the components, right? Network topology. So if you have done some networking course or some research, then you know what they are. So there are different types of topology that you can use. And then the routers, switches, and then edge devices. When you have end devices, end divider just to collect the data, but edge nodes, actually these devices can perform some processing or computation power. So not necessarily all the IoT devices would do both. So then you do end devices and edge nodes. So these are all coming under this the low-level framework. And then when you go to high-level framework, then data and information like routing information. You have routers, and how do you write? How do you route? What sort of algorithm? And how do we forward the packet from one place to another? And encoding, decoding. So there are many functional space, and the previous one was basically a structural space, and now it's the functional space. So how it functions. The reason we are looking at structure and function, along with logical, I mean, that creates the life. So if you look at us, even human, right? We have structure and we have function, running, running, eating, and all these things, and then the logic. So the logic, when you say, okay, so when you drink the water, you won't drop the cup, I mean the glasses, so like that. So you have a conditions. So that's the logic. So the logical starts when you start the low level and high level. When you connect them, how do we connect them? So that's actually how to handle these failures. So sometimes it's failure. So you can connect that, you can connect that, you can connect that logically. Then you connect these two or these four, and connect these four, and then you connect these. So these are the frameworks that you really need to look into it when you do the research, because the data, information, everything flowing through that. So we really need to analyze that. So these are hardware perspectives, system, but when you come to the solution space, we can't do it like inside. So we really need to create some kind of network graphs and then represent these systems as the imaginary agents that what we call, right? So if you look at it very carefully, I mean, these are all systems, but now you can connect to my previous explanation. This could be a router, or this could be a switch. But so each system actually has collection of tasks. So to establish global connectivity and integrate emerging AI technology, you really need to prepare some kind of a graphical framework, and where you can call a system as a node initially, and then it just is a communication line, right? So there's the graphical representation. But more into it, because we want to deploy AI into it. So when you deploy the AI into it, if we take this graph network, so they are systems in terms of ICT, but this system itself is a software system, but it has a collection of some processes that actually required by the AI frameworks. So if you look at it very carefully, that I'm actually zooming into that, so enlarging it, and then such that we could see what exactly is there. So when you do that, this system become an agent. So AI agent eventually turn into AI agent. But this is an agent that can do multiple tasks, right? But in order to do that, in order to connect them, it has to have some knowledge. So that's why you have a structural, functional, logical characteristic. When you add these three characteristics, you basically creating some living mechanism, life into the system. But in order to do that, you really need some learning. So what do? We learn, right? So when you learn, you create knowledge. When you create knowledge, when you start applying, adapting into it, you create intelligence eventually. But what is the evolutionary intelligence? Little different. So we'll look into that. So, but then apply models, then in algorithms, you probably want to optimize something. And then when you look at any problem that has a features, so there's variables. So you create a feature space for that. Once you create a feature space, then you have a knowledge, and then you have the intelligence. Okay. So that's the way to go. So there is a nice paper from Shane Legg and Marcus Hutter that actually talk about the very basic agents, what sort of agent information is required. So if you really want to understand what is agent in a more in-depth manner, I encourage you to take a look at that paper. So the first thing is the model, right? And the next one is the algorithm. But when you look at the model, so we are talking about machine learning because we want to make these ICT nodes or the systems to learn from the environment completely. And then eventually they have to evolve such that the more complex problem, like a multitask, so we could solve. So in order to do that, machine learning is with us for a long time, several decades. You can, but still you can group them into mathematical framework and hierarchical framework and layered framework. When you look at the mathematical framework, I'm not really sure how many already into machine learning, but actually like support vector machine. It was proposed in 1998, but still living because it's actually mathematical, it's more it uses the optimization and all these things. It's still there, but it's slow. So the hierarchical framework, like decision tree or random forest and things like that. Then you have a deep learning. You probably already heard of that. All these large language model and all these things kind of layered initially, but then they started using autoencoders and transformers and things like that. So it was told about my book, so I encourage you to do that. And then it's already 250,000 downloads, and a lot of people are using it. So it's really useful. So the book was published in 2015, and then it's electronically, and then the hard copy came in 2016. Okay, so now the very basic thing is the knowledge, right? So when the machine learning model learns, it makes each node or the system become knowledgeable about the entire environment. Okay? So in order to do that, you really need the parametric model. Imagine a very simple example. You are cooking something, you really want to put some salt. So you don't know how much salt to put. That's the variable. But then as you're being trained, you will know that actually alpha X. Alpha is the fraction of that variable. So if you take a pinch of salt, but you won't put all of them, you probably put little, right? Alpha. So that's the parameter. So how do we optimize it? So when you're a very good cook, then eventually you have to, if 100 people eating the food, and then if 96 people loved it, then you have a kind of optimized parameter. So that's why we create a parametric model so that the system can learn. When you learn, then it's going to vectorize it with the many features, and then it parameterizes it. And then imagine when the machine learning learns. I mean, you can imagine like you, for example, you learn from a book and go to an exam, but you don't take entire book with you. So that means inside the brain, you basically reduce the dimension of the book. So you're not going to take the book to the exam. So that's a dimensional reduction. So when the machine learning learns, we should not allow that the machine to use the entire feature space, but it should reduce the dimension of the feature vectors such that it can work efficiently. So the intelligence, the next level is intelligent. Once you learn, then the next step should be developing an intelligence. So the knowledge coming from the model, intelligence comes from the algorithm. So you use some sort of algorithm. But when you use the algorithm, you optimize it. But in some cases, you have to parallelize. So parallelize also type of optimization. But then eventually there are three, the mathematical or statistical mechanism that's very useful in building the AI system. One is Bayesian. So the Bayesian suggests that basically it's a belief update. So you have some belief, but when you keep learning, then you update your belief, but under uncertainty, because it's not going to be certain while you're learning, but under certainty, you are updating. So that becomes Bayesian. So this is very, very useful in the ICT environment because each node is a localized system. So they are in uncertainty. It is in uncertainty because it doesn't know the knowledge of all the others, right? So Bayesian. And then the other thing, so imagine that you want to work under forgetfulness. So you are in a state, but you forgot everything previously, but you still have to move forward. So that's the Markovian approach, right? So Markovian is going to do the state update, because going in the state under a certain condition, which is a forgetfulness. So you basically forget, right? And then the Laplacian is the gradient. Say, for example, if you have the knowledge that you built a function, so as you learn more and more, get experience, this curve going to become smoother rather than jumping like a discrete. So then what is going to happen over the curve is going to have a gradient. So you need to update the gradient in the direction, which direction it goes under, smoothness, because the graph is actually smooth. So the more you train, the more smooth that becomes. So then the more reliable the gradient. So that's why the gradient learning is very important. One of the new techniques currently working on is basically human gradient artificial intelligence. How as human, we basically apply our intelligence over multiple generations. Okay, so the generation by generation. So as a collective intelligence, not an individual. So the Laplacian is useful. So these are the techniques that you have to think about. So now let's move on to the current emerging technique that we have. Is a multi-agent AI system, right? So that means that the single AI is a software system, but which consists of AI-based models, so the algorithm, and it can solve problems autonomously. I mean, automatically it can solve. But the thing is, actually, if you have multi-agent system, then you can basically create a collaborative environment, and then that's going to give you the collective behavior, collective intelligence. So which is very, very important for IC. Okay. So those are the ideas that we are talking about. But in general, what do we do? That okay, you gain a knowledge, you gain another knowledge, and then you aggregate these two knowledge to create a new knowledge, right? That's the aggregation. But what happens reality is that if you have a problem X, right? So you basically with the other one, you are just modifying it. So which is X plus E, for example. So this creates the adaptive nature in the environment, even in the ICT environment. But the reality in the big data problem is more complex. So you can't just you can do the adaptiveness. So therefore, what we really need is a layer of intelligence. You can see here, this is the ICT layer, which has all the devices and everything. So currently, we only understand the knowledge. We are gaining only the knowledge in the nodes, and then we utilizing it. But where is the intelligence, right? So we need to have intelligence. But intelligence kind of done, But what we really need is the collectivity, because it has multiple nodes. Okay, so that means that now we need to globalize the intelligence. Okay, so in order to create a global connectivity, advancing in that direction, we really need to create the global intelligence. So to do that, you need to have an intrinsic coordination between the agents and then the diversified learning that can create the solution diversity. But what do we have currently to optimization? We all the time focus on optimization. But that is not the case or the usefulness in the ICT environment or similarly. Yeah, even in the disaster recovery, right? So when the people are deployed to fix it, you really need to have not an optimal solution. So you really need to have diversified solution. But at the same time, you also need the decision simplicity to make it. So that creates the decision globalization. So the other thing is the resilience system. The resilience system means that fault tolerance, right? So if one fails, do we have another to help? If it's not, then the entire system basically gone, right? So that's very important. Okay, so in order to do that, a very simple thing is make the ICT as a living organism. Okay, so virtual, it's not like physically, it's like an organism, but in terms of the brain. So you have the ICT system, and then you have a knowledge layer, and then you have the intelligent layer. But what does it mean? So that's the future of ICT. So that's what we are talking about now. That's the next step. So you're going to be ahead of the game if you work on the future of ICT with using the evolutionary intelligence. Okay, so but what is evolutionary system? We learn from the nature. The nature showed us the ICT even long before humans built ICT. That everything evolving, right? Everything evolving. For example, colonies, ant colony, bee colony. So they sense. That means they sense the information or perceive the information, and then they communicate each other, and then they self-organize. Right? If you look at the ant colony, you can see, for example. So the nature is so smart. It can learn, it can create intelligence, and then doing the things which we know that already, right? So advancing the ICT with that, you can see that you can group. One is actually we need evolutionary intelligence, right? Like a human gradient artificial intelligence. And then we need the evolutionary feature space, because feature space is a vector. In a simple concept, I can explain if you take an image, right? So you see so many features in the image. But what the feature vector means, you just basically flatten the image. Okay? So if we have an 8x8 image, a simple example, I don't want to go too much mathematics, if 8x8, you have 64, right? So you have a flat vector, which is the feature vector we are talking about, then there will be 64 features. So that actually, the one image now is actually just single array of features. That's the feature vector. So then we really need that feature space to evolve. So how does it evolve, right? And the other one is it's very important for ICT is the ICT has to explain to us why I cannot transmit this packet, why it actually delaying this packet. So this knowledge should come through the AI. So considering all these three factors, I recently created a basic model for colony of AI, and then that extended that to nature-inspired AI. Okay, so now simply think the evolutionary intelligence. Okay, so the evolutionary intelligence, you can think that two problems as we can take two problems. So the X and Y. Right? So you have an X and Y here, and then what is going to happen? This X and Y basically evolving. Okay, so when it's evolved, that we really need an evolutionary algorithm. I don't know how many of you already familiar with genetic algorithms, and then crossover and mutation mechanism. So this is what happening in our real life, right? So when your parents, they marry, and then the children become the evolutionary product, right? So how do they do? Basically, we have to exchange knowledge. So here what happened in the AI world, the knowledge sharing between this X and Y in the solution space. But here we are talking about in the slide is actually X and Y are problems. So X and Y, two problems, create a new problem. So that, for example, fire and the electric circuits, they create a new type of problem. That's the evolution, right? So we don't want the knowledge aggregation like traditionally done, but we really need the knowledge share. So we already have multi-agent system, but we have to make that as an evolutionary multi-agent system. Okay, so that they produce the new agent that is more powerful. So you have two parents. Okay, so they may overfit, and then they create a child, and then the child agent is going to be more powerful than the parents. So it's going to evolve continuously. And it can evolve generation by generation over temporal domain. So there are two papers here, Colony of AI, and then the nature-inspired Colony of AI. So you can take a look at that. And the nature-inspired Colony of AI, you can download. It is free. It's already there. The Colony of AI is in the SPI library. And if the university is subscribing, then you should be able to get it. Okay, so quickly, if you look at the Colony of AI, and then it basically what happens in this particular case that just take one single model. This is the computer vision-based model. This is called VGG16. So you have that model. So that's the base model. That's the pre-trained model. And then you generate two parents, parent one, parent two, from that model, and then let them share the knowledge. So sharing the knowledge between two parents here named marriage of AI. Okay, so these AI marry and produce a child. So the child is more expected to have more knowledgeable than the parents, but however, you can still retrain, right? So the creating and training AI agent, and then the knowledge sharing, and also the finding from the Colony of AI, if one parent AI agent is flexible, and then the child AI agent is actually nearly 6% improvement that's giving. So then you have a genetic evolution, and then you generate a new child, and you can train, and then you can keep going. But then later on, that's a single model, but you can generate more and more, right? If you have a VGG16 a base model, AI model, you can actually create many parents. You can pair them and then produce child. So then you can basically create the child trained, and then the one child from one family, and then another child from another family can marry, and then they create child. And it's going to grow. The entire ICT framework in the intelligent layer is going to keep evolving and then creating more. So, but that's a single model. So now they realize that there are many models. How do we bring them into the framework, in the evolutionary intelligent framework? Well, you could consider model basis, model by model, but there's going to be too many. But then you realize that where does the intelligence come from? So intelligence comes from your learning mechanism. Okay, so knowledge. So when you learn, you want to create intelligence. This paper suggests that only really need three types of learners. So fast learner, detailed learner, and organized. So the fundamental concept to the Colony of AI or nature-inspired Colony of AI is the evolution of intelligence only from three types of agents, learning agents, which is the fast, detailed, and organized. You can think of yourself. I mean, if you while you are learning, you are all three: fast, detailed, and organized. You must be creating more intelligence in space. So, so this is, you can see that this is the VGG16. So I encourage you to look at the VG16. This is a VGG16 model. And you can see there are 5 learning steps, layers, that the learning steps involved. And within each learning, you can see 2 knowledge. So they create 2 knowledge channels initially. And then you have the dimensionality reduction, for example, and in here. And then you have another 2 knowledge in the next layer, and dimensionality reduction. So dimensionality reduction is coming here, so you can see 112 times 112 and 56 by 56, is keep going like that. So what happened? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's the 13 layer of learning, and then you will have a fully connected layer later on. So the 3 layers, the convolutional layers. So that makes 16. So that's where the VG16 comes. But ultimately, you can see it started from that many dimension as it's really started from 224 by 224, but then it's reduced already here. Keep going. Ultimately, you have 7 by 7. It's like your summarization. You learn from a book, and eventually you have extracted the knowledge, and then that's where these neurons coming from. And then the main problem that it deals with is the classification. So the number of classes here is like 1,000 classes. This is because it's the ImageNet data set was used to do that. There are 1,000 classes. So this neurons is the, you remember that I mentioned that 8-byte image you flatten, right? So that's going to have 64 neurons, the features are gone. But in this process, as you can see, initially started 224 by 224. That's a huge number of neurons there. But once you've gone through this process, you end up with 4,098 neurons. So that's basically your current feature space after flattening this. Okay? So that's an internal mechanism. So the reason I'm putting this one here is imagine that your system in the ICT has a model, VG16 model, for the purpose of vision-based problem. Then you basically have the knowledge extracted from that model. So now within the system, you may incorporate fast, detailed, and then organized learners like this model, and then let them marry. But here, this is categorized as fast learner because the number of layers are smaller than the next one, which is VG19. VGG19 has K1, K2, as you can show here, says 16, and then you will be adding 3 more layers, that becomes 19. Okay, so this becomes detailed then. So if you input an image, it's going to provide you a better knowledge, but the dimensionality is the same, 4006. So now, then they realize here is when you learn through the system, through layer by layer, and then you come back and then learn from a new data point, some point the gradient vanishes. Okay, so that's called gradient, vanishing gradient. It's very simple. It's basically you learn continuously. When you learn continuously, you basically forget what you really learned before. Okay, when the new interesting subjects come in. So mathematically, you can think. So you are trying to learn X, and then you create a learn fx or f1x, then you do f2x, then f3x, then eventually you forgot the x. So what they are doing, basically, they're adding that. So basically you have x, f1x, then f1x plus x. Then you do f2x, then f2x plus x, so that you can remember. So imagine that when you study, you all the time, somehow you go back and forth, and then you loop around and start learning. I'm pretty sure you will have a better learning. So because otherwise you have a vanishing gradient problem in your learning strategy. So in order to handle that, they created ResNet 50. All these the models still AI, but can be connected to ICT in that system. So each system, each node is going to learn. But now you have the fast detail, and so that expected to have a smarter the smarter brain or smarter knowledge or intelligence that can be that information is in this paper, so you can take. So now human gradient intelligence. This is the current research. As you can see, some interesting results. So I assume that you know overfitting problem. Overfitting means that we train the machine learning. Okay, the training accuracy is 100%, for example, and then your test accuracy is lower than 70%. Okay, so you basically have the overfitting problem. So I mean, because you're overfitting during the training. So the big difference, right? So you can see from here, this is actually a training set and this test set for a particular parent. But also imagine that I'm not superimposing here or enlarging the or emphasizing too much on the accuracy. You can see that I'm starting from 0.93. But if you start from 0, you might not find the significance here, right? But the reason this plot shows basically the this error, okay, the standard error. As you can see, the standard error doesn't go beyond that, okay? So it's very small. So here you can see this standard error is you cannot even see it. So, but overall, as you can see, the test performance is worse than the training, okay? But maybe acceptable, but still low. So that there is a overfitting problem. But now imagine, look at this one here. So after you sharing the knowledge, that's what the marriage means between AI agents, and then you have the child AI agent, you can see the significant jump here, okay? So that from 9.4 to 9.7, 9.8 basically because of 9, right? So you have a higher intelligence that you can see. This is the human gradient intelligence at one generation, but you have to do in more generations there. So this is called human gradient intelligence here. And then the when I was introduced that, you can see that she mentioned about the different areas I worked on. So this is the area of the explainability. Okay, so this is called negation-based explainable AI. So the actual difference of this compared to the current the intelligence space or explainative space is that this is complement, is mean negation. So it explains why the predicted class is not one of the other classes. If somebody, the model is predicting is a cat, okay, so currently is explained why is predicted as cat. But what we are talking about, like, why not dog? Why not tiger? Why not lion? Why not elephant? Right? So the different things, right? So the different, or why not even bird, right? So that's what the difference is about. But this is the model, the concept. I don't want to go through in detail, but I give a simple example for you that might help you. So as you can see, there are three classes here, right? 2, 3, and 1. Say, for example, this is a cat, this is dog, and this is bird, right? So the feature space going to be here. This is the label of cat, dog, and then bird. And then you see X1 and X2 are the features, right? So now when the new data point comes, X1 dash, X2 dash, and then you have a model that predicts as 1. So it says it's the cat. But what we are going to do, we are going to enforce that no, it is not. It is basically the dog. Okay? So that's what is happening here. So you're putting that as a dog. So now what is going to happen, if you reconstruct this feature space, you have more data points, not just 2. This is just an example. Now you can see this new one is added. So now you have predicted one is something different, but you are saying no, they are not. They are the same. Basically, it's a dog. It's not really cat, right? So then what has happened after that? You basically transform this into frequency space. So there are infinitely many frequencies. So you basically use FFT. I don't know, fast Fourier transform. So you can convert into, you can see here, you have X1 and X2. So now we have a frequency of X1, frequency X2. So therefore, a lot of redundant That means repetition. There's so many information, so you have more information. So what will happen now? You can actually, because you assume these are one, these are two. Now you can actually fit a model. Let's take a very simple mathematical model. Suppose if you find support vector machine doing division like that in the frequency space, then now you know that actually this one is not two. So that at that point, it can really explain why this one is not two, but you said you forces it to be two, right? So that's a very simple concept that this uses, but that actually done in a complicated fashion. As you can see, that there are a lot of frequencies going on, spectral density and things like that. So you can take a look at that paper if you are interested. So these are future of ICT that we are. So as I mentioned here, instead of saying, oh, this is cat, you really know, why not dog? Why not lion? Why not elephant? Why not tiger? Why not bird? You ask thousands of things. So what happened, basically, you have a larger space to analyze. And then that is called infinite family of feature space. But beauty of that, we have in statistics and mathematics, you can create that type of mixture model. So one of them is DPMM, richly processed mixture model that create the infinite mixture model. And then you can do FFT to do that. So you can basically create that such large feature space. Then what will happen, you may ask questions like, oh, it's going to be infinite, what do we do? That way we basically create a PCA. But before that, once you created an infinite feature space, you're projecting on the Hilbert space. But what the Hilbert space does is basically going to create, it's a function space, right? It's an infinite function space. So it allows us to create the inner product operations. So you fit a vector, and then vector, you can do the inner product, and then you can get the new vector. So then you reduce the PCA. With the PCA, you reduce the dimensionality, as I explained to you before. So that's the other thing that we can apply to CT. And then I'm showing here the beautiful results. For example, if you take three birds, right, cardinals and the American robin and the house finches, and you can see that without this FFT boost, which is a Fourier transform, it gives you this accuracy. This is called ROC curve. You're probably already familiar with that. I'm not 100% sure, but this applied RF, you can see the accuracies. This is the key part. You can see that. But as soon as you put FFT, you can see it jumping into 95, 96. So that indicates that the frequency space basically carries the required information. Okay. Yeah. So I think it's done. So the concluding remarks is I don't want to put too much big list here, just 2 points that so that you can take it yourself and then think about it, connecting with the question I asked before. The artificial intelligence must evolve knowledge and intelligence, autonomous themselves, right? Just as nature does. So with fast learner, detailed learner, organized learner, and combined, you can do that. Right? And then the ICT, if you look at the system is, I mentioned this is a node, right? The node has all the models, algorithms, knowledge, intelligence, etc. So that update the knowledge and adapt structures and refine decisions and evolve intelligence and self-organize like the same way the nature does. Okay, so this is my detail. If anyone wants to contact me, feel free to do so. I mean, I'm happy to help you, especially students, if you really need any help based on this one and whatever you learn from this conference, and then you really want to discuss with me along this line, feel free to do so. Okay, so if you visit, this is my university email address, this is my profile, so you can take a look at it. And then this diagram is created and collaborated with ChatGPT, right? So it's a beautiful diagram that I love it. Okay, so that's all. Thank you very much.
What a wonderful distillation of expertise from Professor Sudharan. Thank you very much,
Thank you.
Professor, for expressing your knowledge at our conference today. And we are deeply grateful for your presence here. So,
Okay, so now it's time for a quick break to get you refreshed for a day full of knowledge. But before proceeding with refreshments, let me introduce the next few items in our agenda. First of all, we cordially invite all of you to be part of our group photo. It will be taken at first floor lobby, where the registration desks were located. After that, you are cordially invited to enjoy your refreshments. Then after that, we have arranged a series of technical sessions which will start around 11:15 after you enjoy your refreshments. And those series of technical sessions will include a session on computer vision conducted by Dr. Kasun Chinasena and Dr. C.R.J. Amarraj, which will be held at 4th floor auditorium 2. And then another session on data analytics by Dr. Chamara Liyanage and Dr. Saminda Premaratna in 3rd floor auditorium 1. Then a session on digital economy, financial technologies and cyber security by Dr. Isiru Manavadu and Dr. Upeksha Ganegoda in 3rd floor auditorium 2.
we also have 4 parallel sessions planned for machine learning and deep learning, the first of which will be chaired by Dr. Sandareka Vikramanayaka and Dr. Chatrika Sevandi Silva at the 2nd floor lecture hall 1. The second session will be chaired by Dr. Asanka Gunawardana and Professor Tushari Silva at the 1st floor lecture hall 2. The session chaired by Dr. Rukshima Dabare and Dr. MFM Ferdaus will take place in Lab 3 on the 3rd floor. The final session, chaired by Dr. Sandon Dasanayaka and Dr. Jana Chandra, will take place at Lab 1 on the 1st floor. We also have an invited talk happening at this hall on heterogeneous server queuing models in fuzzy environment, conducted by Dr. R. Ramesh, Associate Professor, Agrinar Anna Government Arts College, India, and this session will be moderated by Professor H.U.W. Ratnayaka. The invited talk will be followed by a technical session on foundations of artificial intelligence, and it will be chaired by Professor Ratnayaka and Dr. Ramesh. So we invite everyone once again to take part in these technical sessions, and with that, we would like to take a moment to thank our our exclusive banking partner for today's event, Commercial Bank of Ceylon PLC.
Your way. The power to be a trendsetter. The power to invest in your dreams. The power to spend more time with loved ones. The power to progress wherever you are. Power to you with digital banking from Commercial Bank. Commercial Bank, our interest is in you.
Thank you very much. Once again, that was our exclusive banking partner of ICITR 2025, Commercial Bank of Ceylon PLC. And one more time, after the technical sessions, the organizing committee would also like to extend the lunch invitation to all participants at 12:45 p.m., although the time may vary due to agenda changes. Please enjoy your lunch in the open area, and we will see you back at the auditorium around 1:45 p.m., time permitting. So once again, you may now disperse for refreshments, but before that, please head down to the lobby area, the registration desk on the 1st floor for a group photograph, and when you return back to this floor, we will have refreshments ready for you. Thank you.
Patrons in the system, NS, summation NPN, then predicted aggregate of patrons served, E of CS, mu summation mu PN, and average renaging rate, average retention rate. These are all 4 formulas. So this is the approach of cost. So that is the cost experience. We have more symbols and we have 3 formulas: aggregated expected cost, aggregated expected revenue, and then aggregated expected profit. These are all 3 formulas. So then this is the new idea, centroid of centroids fuzzy ordering method. So this is the ordering method to defuzzify the fuzzy numbers. So here we have noted that centroids, but we have taken interval valued type 2 fuzzy system. So therefore upper membership function and lower membership function. Also we got the 2 centroids, GU and GL. Okay. So for the upper membership function, we have the centroid GU, and a lower membership function, we got the centroid GL. So this is the type 2 fuzzy number systems. So with this idea, we got the fuzzy ordering formulas. That is, finally the ordering function IVT to Fn, that is AU, AL is R of A. So ranking of A, that is R of AU plus R of AL by 2. So this is the mean. So with this idea, we have taken one example since a long year ago. In India, particularly Tamil Nadu, the most prestigious Pongal festival is celebrating by all Tamil people. Usually the government of Tamil Nadu is dispatching the Pongal gift hampers through the ration shops. During those periods, a very long queue is formed by the people in front of the ration shops. Think about a particular ration shop dispatched the Pongal gifts along a single server queue. So here we have some customer arrival rate, service rate, and distribution parameter, and fuzzy ordering approach. So we have tabulated by our formulas or by our models the performance expedients. So this is one performance measure. So next we have taken, or we have drawn with the tabulated values by the graphical representation. So next, the cost expedience, we have 3 formulas, already we know that. So by our idea, we have taken the arrival rate and service rate and distribution parameter. We have tabulated by our formulas with the fuzzy idea. We have tabulated our answers. So the table values gives the graphical representation also. So this figure 9 shows that the increment in the probability Q makes the steady state decrement in AEC. So this is a fuzzy heterogeneous system. Heterogeneous system means not equal. So service rate is not equal. One server may be fast, one server may be slow. This is the heterogeneous idea. So we analyze the cost and profit appraisals of heterogeneous queuing system by trisectional fuzzy ranking approach. Previously we have taken centroid idea. This is the trisectional fuzzy ranking idea. Okay. So ranking functions are dominated a momentous role in defuzzification. So here we have taken bulk arrival queues or batch arrival queues. So heterogeneous servers queuing system have applications in computers and many other fields. So here let us consider Markovian heterogeneous system queuing system. The customers are arrived at single channel queue in respect of Poisson process with average fuzzy arrival rate lambda. So here when only all the service is free, the arriving customer occupies the free server. This is our idea. Basically the idea is here. When both the servers are free, the arriving customers chooses the fast server. This is nature. With the fuzzy probabilities phi1 and phi2, and also phi1 plus phi2 is always 1. Okay. So Pn be the steady state probability that there are n units in the system. So n equal to, we have taken n equal to 10. So therefore P10 be the steady state probability with no waiting line. So here P01 be the steady state probability that the server 1 is free and server 2 is engaged. That is the symbol P01. Or P00 means steady state probability for there are no units in the system. These are all symbols. So P2 equal to P11 and P1 equal to P10 plus P01. These are all probabilities. So we have some basic formulas from the basic queuing theory formulas we have here. So here probabilities are summation of probability, all probabilities always 1. So therefore we have some formulas ns, that is expected number of customers in the system. This is our model, and average reneging rate. This is our another model. Also average retention rate. This is the last model. So here the total expected cost means TEC, TER, TEP. So this is our idea. We have to find it. So by our trisectional fuzzy ranking algorithm, here also we have taken the in center. Okay. So previously we have taken centroid. Here we have taken in center idea. So by this idea we got the ranking function. So also the numerical example, we have the values of arrival rate and service rate mu1, mu2. So because why? Because mu1 and mu2, here this is the heterogeneous servers. One server may be fast server, another server is maybe slow server. So the service rates are different. So then only we have mu1 and mu2. So with this idea we have calculated by our formulas, and first we defuzzify the fuzzy numbers R of lambda, R of mu1, mu2 and so on. So by our formulas, by our ranking ideas, we have tabulated the answers with this table, and the table gives the graphical solution. So this is the graphical solution. So we have 3 measures, so 3 graphical solution. So this figure shows that if we increase the values of Q, then the value of TEC, total expected cost, is partially decreased and partially increased. Figure 2 and 3 shows that if we increase the value of Q, then the value of TER and TEP, total expected revenue and total expected profit, are increased. These are all our upshots. So here this is our conclusion or upshot. We have examined the new manner for finding the cost and profit appraises of heterogeneous queuing system by trisectional fuzzy ranking approach. We may use this technique for various fuzzy queues instead of using existing techniques. This technique not only gives the crisp values but also gives more accuracy than the other values. This manner will be useful and helpful to all the researchers and inventors in the succeeding days. So these are all our references. Thank you. Any questions from you?
Professor Ramesh, I was wondering, so are there any applications for servers? You are focusing on servers, utilizing servers, isn't it?
Yes, ma'am.
Right.
These are all applications only, but mainly if we want to service, we are going to the service with the help of queuing terminology. First, the input going to servers, they form a queue. So we have more queues. After that, they got the service. If they got the service, they exited from the system. This is the basic queuing system.
Yes.
The applications are various applications. Suppose the heterogeneous system. Heterogeneous system means 2 or more servers. The servers are 2 or more, not a single server. Because heterogeneous means different service time. So 2 or more servers here in the system. So one server may be fast server, another may be slow server. Okay, this is heterogeneous. So more queuing system are there.
Right, right. So why do you say tri-sectional?
Yeah, this is one idea. This is
Ah,
the
that's
ranking
our
idea, our finding idea. Okay, so
Right.
this is we have more ranking ideas using the centroid, in-center, ortho-center, more idea. That is the distance method ranking system or area-based ranking system. So this is the distance-based ranking system. So then only we find out the in-center or ortho-center or centroid. More or less, this is the distance-based ranking system.
Right.
Yeah.
Okay, thank you very
Thank
much
you.
for the good
Thank you.
explanation. Yes. So on behalf of the research session, I would like to give my appreciation for the plenary session, and thank you very much, Professor
Thank you.
Ramesh.
Thank you. Thank you. So next, the next session is a paper presentation session, I think. Okay, no problem.
Thank you, Dr. Ramesh. Please welcome the session chairs for the track foundation of artificial intelligence of the ICITR 2025, Professor H.U.W. Ratnayaka and Dr. R. Ramesh. Professor H.U.W. Ratnayaka is a senior academic at the Open University of Sri Lanka with expertise in data mining, artificial intelligence, and technology-enhanced learning. She holds the PhD from Murdoch University and has extensive experience in teaching, research supervision, and publishing in computing and AI. Dr. R. Ramesh is an associate professor at Arigna Anna Government Arts College, India, specializing in operations research, queuing theory, and fuzzy systems. He has published widely in applied mathematics and contributes to research on heterogeneous server models, performs analysis and decision marketing in uncertain environments. We are honored to have Professor H.U.W. Ratnayaka and Dr. Ramesh as our session chairs, and with their expertise and guidance, we confidently hand over the session to them to lead the discussion and the insights of foundation of artificial intelligence. And I would like to tell common guidelines. You have 10 minutes for the presentation and 5 minutes for the Q&A session. At the end of 8 minutes, you will hear a ring, and at the end of your time, you will hear 2 rings. Thank you.
So today's first paper presentation is paper ID 63, Pre-trained multilingual models for low resource Sinhala automatic speech recognition enhancement. Presented by, is it Inuri Harishchandra? May I know the presenter? Is it Inuri Harishchandra who is presenting? The co-authors are Sasangi Nayanatara, Tamir Veerakon, Randil Pushpananda and Ruwan Veerasinghe. Over to you.
present the paper pre-trained multilingual models for low resource Sinhala automatic speech recognition enhancement. First of all, automatic speech recognition or ASR is use of ML or AI techniques to process human speech into readable text. So over the past few decades, ASR has improved their accuracy. However, still most of the research studies has focused on high resource languages like English. When it comes to the low resource languages like Sinhala, still there is a gap to enhance the accuracy. So one of the major reasons for this issue is having lack of large data sets. So during this research, we have mainly focused on how to enhance the accuracy of low resource ASR systems even without having a large data set. So let's explore the related works. Starting from statistical methods in 1980s, ASR has progressed through large vocabulary continuous speech recognition in 1990s. After that, during 2010, deep learning and neural networks were introduced. And finally, starting from 2020 to present, end-to-end models are being used. There are two main approaches can be identified for ASR enhancement: traditional hybrid approach and end-to-end deep learning approach. When it comes to the traditional hybrid approach, there should be three separate models: lexicon, acoustic and language models to generate the final text-based output. When it comes to the end-to-end deep learning approach, it will directly maps speech input into text output. Let's move on to evolution of Sinhala automatic speech recognition systems. The first ASR research was conducted around 2011, and during this phase, most of the research studies has focused on traditional hybrid approach. And during 2019, the first deep learning approach was introduced, and finally during 2023, one of the most latest Sinhala ASR research has used deep speech model with transfer learning techniques with a word error rate of 17.19% and a character error rate of 5.9%. So we use this model, this research as the benchmarking research reference for our project. These are some open source ASR toolkits and models. During 2011, Kaldi was introduced, and during 2014, deep speech was introduced. As previous studies, most of the times has used deep speech model and the Kaldi. So during our research, we have mainly focused on these multilingual pre-trained models, Wave2X2 XLSR, Whisper and Wave2X2 BERT models to enhance the accuracy of low resource Sinhala ASR using transfer learning techniques. So let's move on to the research approach. As the first step, data collection. As the data set, we have used the speech data set from Language Technology Research Lab at UCSC. In this dataset, the transcriptions were originally in CSV format and the audio files were in WAV format with 40 hours of speech data with both male and female speakers. There are a few reasons for using this UCSC LTRL dataset. The first one is speaker variability. As I mentioned in the previous slide as well, this dataset was created using both male and female speakers, and each speaker gets 200 sentences with the first 50 of common sentences and the next 150 with unique sentences for each user. And another reason is variations in recording conditions. As an example, this dataset was created in both noisy environments as well as studio environments. The next step is pre-processing. We used the same test set used in the benchmarking reference, and the remaining data was randomly split into 80% and 20% for both training and validation. And the transcriptions were cleaned by removing special characters, and finally audio files were resampled to 16 kilohertz. After that, we have started training our dataset with multilingual pre-trained models using transfer learning. We used Whisper, Wave2X2 XLSR and Wave2X2 BERT models to do our experiments, and with this 10 epochs and the given learning rates. And finally, Hugging Face was used for version controlling. This is the transfer learning process we have used during the research. After the feature extraction, our dataset was fed into these pre-trained multilingual models, Whisper, Wave2Vec2 XLSR or Wave2Vec2 BERT, and in all the three pre-trained models, in the architecture of these models, there are multiple layers, including the low-level layers contains more general patterns to all the languages, and the top-level layers contains the language-specific patterns. So we freeze the low-level layers, which contains the data for all the languages, and only replace or modify the top-level layers, and finally the fine-tuned Sinhala model was created. So these are some outputs generated from all Whisper, Wave2Vec2 XLSR and Wave2Vec2 BERT models. As you all can see, the results generated from the Whisper model contains replacement symbols indicating character encoding issues, and also there are spelling errors and spacing errors as well. And when it comes to Wave2Vec2 XLSR model, the character encoding issue was resolved. However, still there are spelling errors and spacing errors. When it comes to Wave2Vec2 BERT model, the character encoding issue was resolved. However, and also very few spelling errors and spacing errors. So to do the evaluation of these three models, we used word error rate and character error rate matrices, and lower the word error rate or character error rate means better accuracy. So these are the results generated from experimental models. Our Wave2Vec2 BERT model could achieve 1.79% word error rate and 0.33% character error rate with the best results. And let's compare the results with state-of-the-art model. Here also our Wave2Vec2 BERT model could achieve lower word error rate and character error rate when comparing with the benchmarking reference. So this graph also shows the result comparison of our experimental models and the benchmarking reference. And our Wave2Vec2 BERT model could achieve 15.4% improvement over the state-of-the-art model. So as future works, we suggest to integrate an external language model or apply advanced post-processing techniques to further improve the accuracy and explore real-time speech recognition capabilities. And finally, the most importantly, investigate code switching handling like Sinhala and English. So thank you so much.
Nice presentation.
Thank you.
How many models?
How many models have you taken for comparison?
We compared the results with only one model. We did experiments with 3 models.
No, you have taken 3 models.
Yeah, for the 3 models, we do the research based on 3 models using transfer learning techniques. We use only one model to compare the results with.
Do you have any data for that comparison?
Sorry?
For comparison, do you have collected any data?
No, we use the same testing data set which has been used by the comparison model.
Which model is best one?
Wave2Vec2 from our models, fine-tuned Wave2Vec2 BERT model got the best results.
I have one question. Why do you say it's a low resource language?
Because Sinhala is low resource language and there is a gap to enhance the accuracy.
So, yeah, I'm asking why do you say it is a low resource language?
Because we have limited data sets. Because of this reason.
Is the only reason is the number of limited data sets?
There can be many reasons, but we use this as low resource because we have very limited number of data sets.
Number of data sets. Okay, okay. So you gave few future work. So what do you think you can do more to improve the system?
I think to improve the system, the third point is better because still we have not do experiments with code switching like Sinhala and both Sinhala and English speak mixing. So I think it's
Okay. Okay. Thank you, Inari. Thank you. Good. Come. The next paper, paper ID 66, parameter efficient fine tuning of LLMs enhanced with RAG to assist students with lectures. Presented by Ilma Jiyad. Co-authors are S. Thirukumaran and Nagulan Ratnaraja.
Okay, good morning everyone. So I'm Ilma Jiyad and I'll be presenting my paper titled Parameter Efficient Fine Tuning of LLMs Enhanced with RAG to Assist Students with Lectures. So giving these are the contents that I'll be walking you through. So giving an introduction, so taking notes during lectures is very important as lecturing is the predominant method of conveying important information for students within the higher education system. So studies indicate that there is a strong correlation between the amount of information gathered in from the lectures and students' test performance. So, but note taking in the sense is a cognitively complex task which requires the students to attentively listen, take down the important points and understand them and quickly write down them, which places a heavy working load in students' memory. And moreover, some students focus too much on writing down everything what is being taught, and some other students even forget what they have just learned within the lecture, even just after lectures. So, although few studies have been conducted in order to help students with lecture note taking, as summarized in this table, so we identified few gaps in them, which is summarized here. So, typically, none of the studies focus on helping students with past lecture recall and revision. And existing research, they do not have an automatic method to extract the key announcements and off-topic removal from the lecture transcripts. Furthermore, the existing studies, they relied on pre-trained resource-intensive LLMs, which require a certain subscription or keyword extraction mechanism for note generation. So, in that, so we aim to develop a tool, automated lecture note-taking tool that could automatically identify the key announcement, remove off-topic contents, and also help students with question answering based on the lectures, and also generate questions based on the lectures held so far in order to improve student comprehension. So we had the objective of identifying compact LLMs that could be efficiently fine-tuned with available hardware resources and analyze the model's ability to handle long text and do a comparative evaluation of the LLM with RAG integration. So this was the methodology that we had followed, which started with data set creation and then the automatic speech recognition selection. So in this case, we had selected Assembly AI due to its accuracy and speed. So talking about data sets creation, so as we didn't have available data, so we had to create a data set which consisted of instruction, input, which is the lecture transcript, and the output, which is the lecture notes in point form with highlighted important points. So at the very beginning, we didn't know how LLMs would behave with a long text. We had to create two sets of data, one with a small lecture transcript and other with large lecture transcripts. So then using this data, we had done parameter efficient fine tuning on LLM to choose the base LLM that we could be using for the tool development. So as full fine tuning was not possible with the available hardware resources, we had done parameter efficient fine tuning with LoRa adapters. Specifically, we did supervised fine tuning. So once we had chosen the LLM that performs well upon fine tuning, we set up the RAG. So to evaluate the RAG as well, we had created a data set. So based on the lecture notes that were stored in the RAG, so we had created a question and ground truth answer pairs to evaluate the RAG. So this is for the RAG setup, we had used ChromaDB open source one as the vector store, and all mini LM as the embedder to convert the tokens into vectors. And the retrieval strategy was based on two methods. One was metadata filtering, because when the note was generated, it was stored in the RAG along with the metadata, which is the lecture date, and then the top case similarity. So this is the overall architecture of the developed application, where we had used React.js for front-end and Fast API back-end. So as during the time of inference, we had not got an inference API for the LLM. We had to use Gradio client interface for LLM inference. So talking about the results and discussions, so to choose the LLM that would fit our purpose, so we initially started with a Tiny Llama 1.1 billion parameters. So as it was small in size and it performed well over fine tuning as mentioned in the Tiny Llama paper. And when we fine tuned it on small lecture transcript, so you can see the above table, so that's the result. So it performed well, but when we fine tune it on large lecture transcript, so the results were it was unimaginary, like it gave meaningless words, and the scores went to minus. So when we analyzed that, we identified that it was due to the reason that we had trained the LLM above its context, with text above its context length. So now that imposed a new challenge on us, that to identify an LLM that had capable context length, and also we could effectively fine tune with available hardware resources. So then we choose Llama 3.2 and 534K mini. So then we had done a comparative value which had larger context length. Of course, Llama 3.2 was of 8K tokens and 534K mini was of 4K tokens. And we had done a comparative evaluation. So this is the results with small lecture transcripts. Although they perform well on small lecture transcript, when we fine-tuned it on large lecture transcript, the scores eventually dropped. So even then, so we identified that there's nothing to deal with LLM's context length and its ability to handle long text. In fact, LLMs get confused in the middle of the text. So then we had to follow an alternative approach of splitting the long lecture transcripts into overlapping chunks, and each of those chunks was fed to the LLM fine-tune on small lecture transcript to generate the note, and finally those notes was combined to form the final lecture note. So these are the evaluation results using this chunk merge strategy. So here 534K mini performed, fine-tuned 534K mini, fine-tuned on small lecture transcript performed better than Llama 3.2. So when we analyze in somewhat deeper into the results, so we took the precision and recall separately for 5.3 mini. So you can see the recall is higher than that of the precision. So precision is low. So when we analyze what was the reason, So precision is the ratio between the number of overlapping words over the number of words in the generated summary. So then that means the number of words in the generated summary is higher than that of the number of words in the reference node. So then that was due to the fact that we had followed a chunk merge strategy where the chunks were broken into overlapping chunks. So however, as the recall is higher, so it says that there is a great similarity between the recall and generated summary and the reference summary. So then we took 5-3 mini as our base model, and these are the scores before fine tuning and after fine tuning. So you can see the scores have increased after fine tuning. And also using the data set created for RAG evaluation, we had evaluated the RAG system component wise and the end-to-end pipeline. And moreover, we had used these questions to evaluate the system with RAG and without RAG. And each of the responses was classified manually classified whether it is hallucination or non-hallucinated. And the hallucination rate was taken as the ratio of the number of hallucinated responses over number of responses. In the case, we identified 43.33 hallucination rate for the LLM without RAG, and LLM with RAG, the hallucination rate was 6.33, where the hallucination rate had dropped by 37%. And also we had used a small pool of users and identified the performance on the developed system, which is shown as in this slide. So these are the screenshots of the developed application which is run on local. And in conclusion, we were successfully able to develop a lecture assistant tool on our available resource constrained hardware resources. And although it had the successes, some of the limitations are due to the computational constraints, so we couldn't deploy it locally. And quality of the nodes dropped when it highly rely on whiteboard explanations. And future works could include optimizing the tool for mobile platforms and incorporating ASR system that could transcribe multilingual classroom lectures and extend the tool for video-based lectures. So these are the references, and thank you.
The fine tuning is capable for all LLMs.
Yeah, it is capable, but we should have enough resources to fine tune that. Obviously, I didn't fine tune it on my local machine. I had to use Google Colab T4 GPU for fine tuning.
Okay.
The accuracy?
Accuracy
So
of
did
the
you
LLM.
get, now you wanted like the main points highlighted, etc. So
we had created a data set. So we split the data set into two, one for training and other one for the testing purpose, just like machine learning. Then once it is fine tuned, we would give that test data set and see if the LLM generates node as in the test data set. Do you understand?
because it's a lecture.
Yeah.
So unless that is translated.
Yeah, we create a data set. So for each lectures, it would be transcribed, and for each transcript, we will have the lecture note created. So in that way only we created the data set. So then using the test data set, what we do is, we will feed the LLM and see if the node generated would give the similar node which is as in the test data set.
Okay, thank you. So the next paper is paper ID 89, Icitr AI, Programming Assistant for Legacy Code Bases, presented by TTL Denuri. Are you Denuri? Yes. And the co-authors are S. Raghunathan, WAD in Vijayasekara, MD Prageet, ATP Silva, and L. Attanayaka.
Hello everyone. So this is my research along with my colleagues, Akilon AI, Programming Assistant for Legacy Code Bases. So I'll be presenting from the introduction to the future work. So let's come into the introduction. So inside many organizations, there are still legacy programming languages used, or we can, there are also closed source internal languages as well. So these languages are essential for running critical systems, maybe inside their own organization, or maybe if it's an IT company, they might have built software systems for other organizations as well. But when it comes to these legacy languages, learning them, maintaining them, and extending them is not easy. So the problem, if I state the problem in brief, legacy systems depend on outdated manuals and poor documentation. So obviously all languages doesn't contain so much of documentation and AI support, let's say. And these existing code bases are complex and difficult to understand. Say we have a system that is written by another person, that's already hard for us to understand. So think of a language that you don't understand or you're not familiar of. Then if you are going to be a tech employee, you're going to fall in a great difficulty. And then maintenance becomes slow, risky, and error prone because of this. Say your system is very critical and you want to update it, and you can't do it because it's really risky and error prone because you don't understand the language. And skilled developers for these all languages are becoming rare, along with the team struggles to update and extend the systems. So this leads to higher cost and technical debt, as well as inefficient operations inside organizations. So when it comes to existing systems, there are several existing systems that offers this AI support for programming languages, starting from GitHub Copilot, Source Code, Source Graph Code, Tab9, ChatGPT, Amazon Code Whisperer. I mean, these are good, but there are some limitations when it come into a whole. So they have only limited support for legacy languages, or let's say your company has your own internal language, there won't be any support on the internet or AI. Then poor multi-file and full project code based awareness. That is, if you have a repository full of a language you don't know, the AI won't know what's inside that code base. So he might hallucinate and tell several things about your specific programming language, but will never know your code base. And lack of external documentation and web knowledge integration, along with some AI tools which are good, might have a good knowledge on these programming languages, but they don't ideally have an IDE integration. So, as the first stage of this research, we focus on the Perl programming language, which is widely used globally, but now even in universities, maybe schools, they don't teach this language because there are more high-level languages than this. But still, there are critical systems running worldwide. So our solution is Akilon AI, which is the first part is a chat assistant. So it contains the normal chatbot as well as it's session-based. Along with it has the features like integrating your GitHub repository, integrating then putting up web links if it's useful, and then even uploading PDFs. Along with that, the second part of the solution is the IDE integration, which is connected to our chatbot. So basically, this also have several features. So let's see how this works. So what Akilon AI offers, basically, the normal things, which is basically generating and explaining the legacy code, which is not really good in the AI solutions. So what we basically want is when we have to update a system, we need the AI to understand our code base, the existing code base, not just the general knowledge. So yes, so this Archelon AI understands the entire repository through RAG architecture. So once the user gives the GitHub link, it can go through the entire repository and provide you with the suggestions, error debugging according to the context that is already in the code base. And also this maintains session-specific knowledge bases for accurate context, supports PDF, websites, and GitHub repository injection, as I said. And then when it comes to the IDE integration, the first feature is it has inline ghost text suggestions powered by the actual repository context, then alternative implementations in the custom sidebar. This is done for the VS Code, if I didn't mention, and real-time error detection with clear explanation. So this also basically has the automatic context retrieval for up-to-date workspace understanding. So these are the technologies that we use, starting from the fine-tuned model, Qwen 2.5 coder, 3 billion. So this is the instruct model. So we are able to fine-tune it with a small data set. As it says, quantity or quality over quantity, we have used a small Perl-specific data set, which makes the fine-tuned model to integrate the retrieved chunks from the RAG architecture. And then we have used the Gemini API just to create session names for each session in the chatbot. And then we have used the RAG architecture to give the context awareness from the existing repository, and also context awareness from the PDFs and the websites you upload. And we have used two vector databases, that is FICE and LanceDB. You might be wondering why two. The first, FICE, is because it's lightweight and it's created own local storage for each session. That was very easy. That's why we went with FICE. And then we have LanceDB. We use LanceDB for our IDE integration, because LanceDB has the ability to store metadata and file structure inside it, and also it's quick. So when we make a change in the IDE integration, it automatically chunk it and embed it again in the vector database once we do a small change. Then we have used LangChain to basically help with the RAG. And then the chatbot frontend is done with React, and backend is Fast API along with MongoDB to store sessions to make it better and useful. So this is basically a high-level diagram. So you can see the end user is there, and we have two directions. You can either go with a VS Code extension, or you can go with a chatbot. So in the VS Code extension, every instance makes updates the LanceDB vector database, and when we write a suggestion, when we write a comment, this is sent to the backend along with what is retrieved from the Lance database, and then it will provide context-aware suggestions. That is, the AI knows what's already inside your code base, so it provides you with good suggestions. And then the other way, we have the chatbot, which is integrated with the backend Fast API and FICE as the vector database, along with MongoDB to maintain users and the sessions. So we have used Olama server here to store our fine-tuned model, which is, as I said, Qwen 2.5 3 billion coder. And then if we talk about the fine-tuning was, as the last researcher said, it was not easy to do on our machines because we are using a single GPU. Still, I did it with single GPU. We are using LoRa, and I used Unsloth, a good framework by Google that decreases the resources that we are using for fine-tuning. And then the RAG architecture was done by LangChain along with the vector database FICE and LanceDB. So the benefits for as developers, we get real-time context-aware assistance. So what we want is our AI to understand our existing code base, and this is done by our system. And then faster debugging and fewer errors. This improves the maintainability of the legacy code bases for the old programming languages, or if you are a company that has an internal language, you can do this by your own. And then for organizations, because the developers are more capable of maintaining and updating their own code bases, it reduces the dependency on rare Perl experts, low maintenance time and cost, and improved reliability of mission critical legacy systems. So when it comes to evaluation, I have evaluated it with existing code bases such as ChatGPT and our baseline model Quen 2.5 code. So basically they don't have the ability to understand the existing repository, even though they have the ability of web scraping. So I have used a small pilot, I have done a small pilot evaluation with tech students covering 4 universities in Sri Lanka. That's clearly mentioned in our research. So in that case, the repository awareness was like the best, and then the external context relevance was also good, but there was a little problem with the latency because it's running on the OLAM model. So in the future work, we are trying to get it as a enterprise level application, and then we are trying to use better RAG and speed our optimization. So these are our authors. Thank you.
Nice presentation.
Thank you.
Is it suitable for legacy code bases, your Arcline AI?
Yeah, so it's basically, this is done for the Perl programming language as the first stage. So we can extend this to several languages, maybe Prolog, Lisp, the ones that AI is really keen on. So we are trying to do it for languages like Prolog and all, but we have to have a data set of around even 5,000.
Have you tried with another AI idea to this legacy code bases?
Yeah.
Instead of your present idea?
Yeah. I have used it with ChatGPT and all others. So basically ChatGPT and all, they has awareness about the new languages. Maybe Python, they're really good, better than us. But for Perl and all, it wasn't doing well. But in ChatGPT 5, it seems it does.
Thank you.
Last paper presenter is Ms. Madhushani, a fuzzy HP decision model for flood hazard prioritization in Sri Lanka, co-authored by ITS Piyathilaka.
Good afternoon, everyone. My presentation is a fuzzy AHP decision model for flood hazard prioritization in Sri Lanka. This is the here is the overview. Then I briefly introductions, aim, research objectives, literature review, theoretical framework, methodology. Then discuss about the results and finally conclusion and the future works. Then flooding is the major hazard in the natural disaster in the Sri Lanka, and the due to extreme rainfall and the monsoons caused to happen the flood. Therefore, this is essential for the accurate flood risk assessment in the assessment for disaster planning and the land management. For that, we used to using the fuzzy logic and AHP to doing the creating the flood risk index. The aim of the presentation is to develop a comprehensive, spatially integrated flood risk assessment model for Sri Lanka by applying fuzzy analytical hierarchy process within a GIS environmental to improve the accuracy of flood susceptibility evaluation. Then these are the research objectives. First we identify what are the main risk factors, indicators for the flood. For that, we identify the 5 indicators: rainfall, temperature, elevation, deforestation, and the population density. Then we apply the fuzzy AHP for that each indicators and get weights for the each indicators. After that, using the GIS techniques, we we create in the flood risk mapping. And finally, it is provide the insight for disaster management to support mitigation planning and the sustainable land use strategies. Then come with the literature review. There are some international researchers belong with the fuzzy logic and the AHP. Then the first one is the Parsian et al. Then they consider in the they use in the remote sensing data and the fuzzy logic to create in the risk map, flood hazard map. Then they use the fuzzy membership function to create the weights, and using the fuzzy membership functions to normalize in the data and using the AHP to create in the weights. Then they use the then they created the flood hazard map. And the Mokhtar et al., they not using the fuzzy logic, they considering the only AHP method and creating the fuzzy AHP and then get assign in weight. Then they considering the flood risk is the multiplication of the hazard and the vulnerability. Then considering the Sri Lankan context, there is a limits of the researchers in the using the fuzzy logic. Therefore, it is needs to concern about the fuzzy logic and the AHP. Then comes from the theoretical framework. Then I use some theoretical background. Then the first is the fuzzy numbers. Then fuzzy numbers representing the uncertainty of the numbers, and the we compute the fuzzy pairwise comparison matrix, and for that we want to the linguistic scares. Then we use Berkeley geometric methods to compute the each weights for every indicators, and the using the min-max normalization for the standardize the all data set. Then this is the methodology. Then first we identify the main what are the indicators for the flood. Then we data collections and applying the fuzzy AHP and creating getting some weights, and after that using the data standardizations, and finally we calculate the flood risk index. Then comes to the results and discussion. This is the when created the fuzzy pairwise comparison matrix, all 5 criteria are indicated. Then using this fuzzy comparison matrix, the first step we want to know that this is a consistency, verification consistency. Then using the consistency ratio, we get 0.08. Then it is indicators that all judgment are the consistent and acceptable. Then using the after the calculating weights of each indicators, then it is graphically illustrated like this. Then it indicates that rainfall is the dominant flood risk indicator. Then after that we conducted the sensitivity analysis pass, because for that we adjusting the some small values, delta values from the middle values of the fuzzy numbers, and it not change in the weights. It is not changes. It changes very small changes in the final weights. Then as well as ranking of the criteria remain unchanged. Therefore, it confirm that the model stability and the robustness. Then after calculating weight, we calculating the flood risk index. For that we indicate first we standardize the old data set in the using the min-max normalization, and using the after using the normalizations data, we creating the linear combination of all weights and the data and creating the flood risk index. Then the outputs are classified into the low, medium and high flood risk categories. For the model validations, we used to 5 executive date using the 5 dates consecutive date of the 5 dates October in 2023. Then compared with the adversary heavy rainfall notes from the Department of the Meteorology, and we using the we calculating the risk index for all 5 days for the 5 considering the 5 district, and the validation used to confusion matrix. We use high risk is the positive and the low and low medium value as the negative values. Considering the model valuation, we got the accuracy is the 80% and the recall is the 100%. Precision is the 29%. Then it is over predicted. Sometime it is over predicted one. Then this is the finally we created the district wise flood risk map for the 2022 and the 2023. Then finally comes to the conclusion. Fuzzy GI frameworks successfully used for the flood risk assessment. 5 indicators integrate into the composites flood risk index, and the mainly indicating the rainfall is the main indicator. Model validation showed high accuracy and the strong sensitivity. Flood risk map 2022 and 2023 revealed the consistent high risk approach supports data driven planning and disaster preparedness. Then this is a future works. We hope to develop a flood risk predicted for 2025 and beyond, and create fuzzy membership based flood risk index for smoother transitions. Integrate more dynamic factors such as soil moisture, river discharge and the land use changes. These are some references used for the presentation, and thank you.
Nice presentation.
Thank you.
Do you have any ranking function to defuzify the fuzzy values?
What's that?
Yeah, you have fuzzy datas.
Well, can you again?
You are using the fuzzy logic, is it right?
Fuzzy numbers using for the compute the pairwise comparison matrix. And then
you have noted that the fuzzy ranking is used in the first slide and second slide.
Not use fuzzy rank. No. No.
Oh, then how to use the fuzzy numbers?
Fuzzy numbers in the linguistic values and the linguistic value converted to the fuzzy numbers. Then we created the fuzzy comparison matrix. Then it is used after creating the comparison matrix using the Berkeley methods to calculate the weights for the each indicator.
Numbers are used for calculation. You are using the fuzzy number.
Yes.
Either you used fuzzy operations or ranking operations. Fuzzy operation means the arithmetic operations are used fuzziness, fuzzy methodology. Otherwise, you have to use the ranking technology for fuzzy numbers to defuzzify the fuzzy numbers. Then only we will get the results. What method you have taken?
For the defussification methods, I use the centralized method.
Centroid.
Centralized method.
That is the defussification.
For the using the calculating the geometric mean for the finalize get the then we compute the fuzzy pairwise comparison matrix, but after finally I got the crisp size for that. For that first things we calculate the normalize the compare matrix. I used the centralized method for the defussification for these fuzzy numbers.
Okay, thank you.
So are you, have you developed a system with this?
No.
No, for the prediction?
No.
Okay, so you have done the theory part?
Done the theory part.
Right, right. Okay, thank you very much. So we have come to the end of the session. Let me hand over to the
Thank you. As we come to the end of all these insightful presentations, now it's time to give the certifications for the presenters. For that, I cordially invite Professor H.U.W. Ratnayaka to give certificates. Paper ID 63, Inuri Harishchandra. Paper ID 66, MJF Ilma. Thank you, madam. Now I cordially invite Dr. R. Ramesh to give certificates. Paper ID 89, TTL Denuri. Paper ID 167, LKD Madhushani. Thank you, sir. As we come to the conclusion of this session, I want to extend my heartfelt gratitude to all the speakers' participation and especially our esteemed session chairs, Professor H.U.W. Ratnayaka and Dr. R. Ramesh, for their valuable guidance and insights. As a gesture of our appreciation, please accept this token of gratitude as a small acknowledgement of the immense value you have added today. Thank you once again for your time, effort, and expertise. I cordially invite Dr. R.L.C. Sharma to give away the token of appreciation for Professor H.U.W. Ratnayaka and Dr. R. Ramesh.
My name is Yusan Zhang. Now I'm serving as the Vice President of National Taipei University. This talk, I would like to talk about the automatic speech recognition for Chinese dyslexic individuals. This topic is our project. This project is 3 years project supported by the National Science and Technology Council. And these topics is a part of our project. This project title is Digital Support and Embedded Communication Advancing AI-Driven Assistant Technology for Individuals with a Speech Disorder. Professor Yang, please, next to. Now I'm serving as the Executive Vice President for Administration of National Taipei University, and now I'm also got IEEE senior member, and I have many administrative experience, include the Dean of College of Electronic Engineering and Computer Science, and Academy Affairs, and Student Affairs, and so on. Next page, thank you. And then I have also served as a guest editor for SCIE Index Journal, and General Chair, Program Chair, Workshop Chair, and the Chair for more than 1,000 international and domestic conference, and the program committee member for several dozens of international conference. Next page. Here, this slide shows the outline of our presentation. First, I'd like to introduce my topics and the problem, motivation, and the objectives. And then I would like to show the collecting voice and the speech recognition UI we have implemented. And then the system architecture of our system. And then we have conducted many experiments to show our achievement of our project. And then finally, I would like to give a concluding remark. Next page. Okay, I think everyone you will know that what is the dyslexia. Dyslexia is a kind of speech disorder caused by nerve damage or injury, and making speech unclear and or hard to produce. But such a kind of person, how to communicate with others, communicate with their family and their friends and others. Maybe this kind of person, he can type in what want to say using electronic device. But if they have other physical issue, typing get hard too, and so communication become a big challenges. Professor Yang, could you please press the no. This yeah. Yes. Maybe you can hear the voice. This voice shows the two persons they communicate with each other. The first speech sample is very unclear, and because he also have problem with his hand, typing is very, very slow. And the second audio sample is normalized speech produced by our system. So our system can translate his voice into a clear, normalized speech. So this project, our project is built personalized ASR, automatic speech recognition system for this kind of person. Yeah, next. We have known that the current technology, there are many communication boards, such as a picture, a symbol board, alphabet word board, and electronic voice device, and context specific boards and customized boards. This board, they have some problem because it just only can have a limited sentence for this person. Please next page. All right. This slide shows that there are some communication boards. So this can only express limited phrase and cannot fully convey what the user wants to say. Okay, next page. So this problem, the background is a general automatic speech recognition system has trouble to understand dyslexia speech because it cannot recognize their voice. And we have surveyed many tools like Google Speech to Text and the Microsoft Azure Speech, many errors, making it hard for people with dyslexia to communicate with others. So this topics, this project, I want to build a personal ASR system for individuals with dyslexia, and we would like to use the speaker adaptation and the correction method to make speech recognition more accurate and helping people communicate more easily. But they have some problem because each speech impairment issue is unique. So when I collect speech voice of this kind of individual, it's difficult because each patient, they have their problem about the speech. And so we just only can collect a limited amount of speech data to train the personal model. So next. So in this work, we will implement a personalized ASR for dyslexia, the individual. I would like to build an ASR system for dyslexia individual based on the transformer-based. This transformer is use the sense voice mini mode, and I would like to incorporate each user's personalized historical sentence. And we also applied retrieval augmented generation combined with a large language model to build a collection algorithm. After the system is implemented, we validate our approach with 16 individuals with dyslexia. This result showed that average sentence accuracy rate is nearing 80%. And next. So this slide, I would like to show how I can collect voice and speech recognition system. We implement a web page or app to collect user voice, such as left figure. So this figure, a user can use this web page to collect their voice and tell us what he want to say. And after I collect a certain voice file, I can train their model, the model of SR for the certain user. So the user can recognize, use the right side interface to recognize their voice. Okay, next. So in our system, we also implement a web page for our system. This slide shows that we have 133 users registered to our system, and then we have collect over near 5 million 5 million word or voice, and based on the voice, we have trained 36 model for personal XR system. So next. So I also have implement a web page to analyze the system performance. This slide shows that they'll have 56 users to testing their voice, their model. And Professor Yang, could you help me to press the yeah, this video shows that two dyslexic individuals use my app to communicate with each other, and the system this shows that the sentence accuracy rate. This first one is up to the 97% SAR, sentence accuracy rate. Totally average the testing user, we have got the near 80% SAR, sentence accuracy rate. And the next, thank you. This slide shows that our system architecture. In this system, we have two stages to implement our system. The first stage, we have implement personalized speech recognition model, SR. This model, we use the transfer learning from the pre-trained model and then fine-tune the model for dyslexic individual. And the second one is we implement a personal correction module using IIG. This show for stand for the retrieval, the augmented generation. In this stage, we use the language model to build the collection algorithm and collect the feedback to collect the personal corpus for IIG. And so you can see the right side figure. And the first one, personal dyslexia model is fine-tuned. So we can get attempt the personal model for people for person they want to use. and recognize their voice to generate the SR result. And then we use the language model collection to build our system, our algorithm to correct the SR, the result, so that we can get the more accurate and more easily to demonstrate what the user want to say. And the next. So the first one, the transfer learning from the pre-trained model, we start use the pre-trained SR model. This model is sense voice small. Why we use the small version? Because the small version is can real-time use, and because it is faster and use fewer resource than large module. So we use the sense voice small for the pre-trained model, and then we use the pre-trained model to pre-train the personalized dysasia, the model. So then I use the fine-tuned technique to generate the dysasia speech voice file. So how to fine-tune? So fine-tune is the technique, so we can generate and create the personal, the individual model for the dysasia. So this model create a personal recognition model adapt to the general pattern of the target user group. So it perform this model can recognize the personalized speech. So and then produce an SR the result. SR result is Chinese. Is in Chinese. Okay, next. And then we use the language model collection technique to improve the XR output through the post processing. This module have two key parts. First part is personal styling collection. Because we collect the user the corpus, so we can adjust the text to match the user typical the language pattern, such as maybe the person maybe say, I want to eat something, so I can collect this corpus for their for later collection. So we use the history collection. We learn from the past error and the feedback to fix the recurring and the user space mistake. And we collect the feedback. We have a collect feedback loop. This collection module generates a candidate sentence. So based on user selection and the feedback, the module keep improving over time and become more accurate. Next. Okay, let's show the sense mode architecture and the next. And this shows that before and after fine-tune, the CR and SAR. CR is show for character error rate. So you can see that the character error rate can have a significant lower before fine-tune, and the SAR have a significant improved after the fine-tune. Next. Let's show that the second stage we use the historical collection algorithm and personalize the sentence collection system based on the reg. So in the second stage, we need to generate more candidate sentence according the XR result. In this stage, we use the historical utterance matching. This approach is to retrieving a similar sentence from a user past utterance. And then we use the structure generation to produce the grammatical variant based on the original sentence structure. And then we use the n-gram model generation to generate, to produce the possible sentence. So use these three methods to generate more candidate sentence. All right, thank you. Next. And we also use the personal IG and combine with the LLM to create a personal sentence creation system. So right side picture shows the step in this personalized sentence creation system. All right, thank you. Next. So I have conducted many experiments in this system. We use the data set collected from the patient. So we have collected over 56 users to collect to generate the system. But we just only select 16 users to evaluate the performance because there are some users we just collect a limited voice file. So this limited voice file cannot train a well model for recognize their voice. And the evaluation matrix, we use the character error rate and the sentence accuracy rate and the improvement, CR improvement and the SAR improvement. And the next. This slide shows that the evaluation of various pre-trained model. This slide shows that the sense voice small have lower CR than others, and have higher SAR than our pre-trained model. So we select sense voice as a pre-trained model for our system. And the next. This slide shows that the performance comparison of patient with different severity level after fine-tune on various pre-trained model. We have 4 severity level. One is mild, moderate, and the market and the severe. And this shows that the sense voice mode have a lower CR, character error rate. So this shows the sense voice is a good pre-trained model for us. And the next. This slide shows that the performance comparison of CR and SAR on the test set after fine-tune with historical correction. We use the historical correction to correct the sentence, the recognize the result. This shows that the SAR we have got significant improvement for each patient. So this slide shows the historical correction is good for us. Next. All right. And we also make a comparison with other correlation methods, such as BERT, MLM, masked language modeling. We have made a comparison. So the slides show that the BERT MLM do not have a significant improvement on the SAR and on the CER master. And we also made a comparison of CER and SAR on the test set after fine-tune with our IIG collection. So from the table, you can see that the SAR improvement after use the IIG collection, we can get the significant improvement on the SAR. Yeah, Mr. This also shows that the performance comparison of the SCR and SAR on the test set after fine-tune with IIG and BERT MLR collection. This comparison, we can see that when used we use the IIG, we can get the significant improvement on CER and the SAR. And the next. All right. So these slides show that if we use the hybrid LOM collection, what is hybrid LOM collection? We collect various collection methods in our system. We can get a more higher SAR. Okay, so you can see that the right column, the hybrid LOM, the SAR, this can you can see that the SAR is very good. Okay, next. So this show the average, the CER and the SAR different models. This show that we have 4 models. The right side of this figure is show that the average, the SAR is near 77%, 78%, right? Next. All right. So in this, in our talk, in this work, we have built an SAR for dyslexia individual based on the transformer base. Sensible is minimal, and we also leverages transformer based large language model to extract speaker speech specific speech feature from the historical data. And we also implement a dynamic historic collection algorithm to adjust the recognition based on the previous error. And we use the LLM-based style extraction method to build a personalized collection model tailored to individual speech variation. Next. It's so lucky, and because this project can help the person with dyslexia. So we received a lot of many media attention, and we also received many interviews, such as TV station. This is a 大爱电视台 is a TV station the interview, and also accept interview by the NSTC, and also an interview by a radio station. This is Voice of Taipei Radio, and also some printed media interview. 科技妹 is a print video interview and the next and also a printed media interview and second is interview by the radio station and third and the fourth also printed interview media interview. So this project we received a lot of media attention for the project. I think this project is very important for their patient with dyslexia, the individuals. So I think they can help them to communicate with other. So the patient can normally communicate. That is very. I think that's very important for them. All right. Next. So here, thank you everyone for your listening. I think if you have interest in our work, I can have another discussion after this or after this section. Thank you so much. Thank you. Have any question for this presentation?
extending her impact across interdisciplinary and technology-driven domains. Her research focuses on bioinformatics, artificial intelligence, and system biology, integrating computational approaches to address complex biological and biomedical problems. We are honored to have Dr. Samantha Matara Arachi and Dr. Upeksha Ganegoda as our session chairs, and with their expertise and guidance, we confidently hand over the session to them to lead the discussion and insights on emerging computing paradigms. Thank you.
Good afternoon. Thank you very much for you to and especially inviting me to chair this session. First of all, let me start the first paper, present the first paper. Now the paper ID is 25. Now, could you please come forward to the presenter who is going to present the paper ID to belong to the 25? Okay, so now, so you have 10 minutes to present, and there are 5 minutes to question and answers, right? Okay, so the presentation title is Real-Time Control and the Monitoring of the Decentralized Solar Energy System Using IoT and GPS Integration. Right, over to you to present your paper.
Good afternoon. Today present about the real-time control and monitoring of the decentralized solar energy system using IoT and GPS integration. This is the outline of the presentation. When it's come to the introduction, the growing solar adaptation in Sri Lanka, there are a bit increase in the rooftop solar energy system due to the climate concerns and fossil fuel reduction. and expansion of the distributed PV systems. And when considering the existing challenges in the solar energy system, the current solar monitoring lacks the real-time visibility in the household level, and also there are no capability to remotely isolate the during the maintenance and exist generation of the solar energy, and identify the gap between the solar energy and the existing system. There are no GPS-based authentication to verify the legitimate solar device, and also the no utility level dashboard for the administrative to control the network, grid system and solar system. And why we need the new system, the distribute the solar generation, demand smarter and the coordinated grid system combined with the solar energy and the main grid system of the CEB. When comparison between the traditional meters and the nutrient IoT solar monitoring and the proposed system, there are several the comparison. Then the proposed system has the many functions of than the others, and real-time monitoring and GPS verification and utility dashboard. The proposed system has the utility dashboard for the admin panel. When it comes to the objective, the main objective to monitor the real-time solar energy generation in the household remotely, and also we can exactly identify the exact position of the solar unit in the subgrid system, and integrate the automated isolation system and combine with the GPS system to control the disconnect and connect the grid solar energy to grid. When it comes to the material and methodology, the device is combined with the smart solar controller and the software application. And methodology review, the system is proposed to design the architecture to measure, monitor and control and remotely isolate the solar energy system with the grid system. And there are the key hardware to element to design the device, smart controller. This is the proposed design of the smart solar controller. And this is the system architecture. When it comes to the system architecture, the data acquisition are real-time measuring the voltage and current, and control layers the relay switching to grip the grid system. The admin panel can do the connect and disconnect the solar system in the specific area, and location layer GPS based verification, and communication layer the Wi-Fi cloud linking for the remotely isolate the fire-based system, and display the output use the LCD display. This is the data acquisition and transmission flow. The power sensors are getting the data from the solar panel and combined with the ESP32 controller, and ESP32 controller get the data for the cloud database and Firebase and view in the admin dashboard. The remotely control the solar energy system in the individually and the whole system in the specific area. This is the relay control for the grid system. The high current relay module is used to connect and disconnect the solar system in the area, and system behavior, the ESP32 actually relay isolate the PV system. When it comes to the software development, the real-time grid monitoring can show the total solar feed from the selected region. We can select the region and we can monitor the generation of the specific area of the solar, and device control state and subgrid selections, and dynamically updating for the map and metrics, and remotely switch in the solar system. We can disconnect and connect the solar system, the exist generation of the grid system, and geospatial visualization. Google Map can have GPS module has to specifically identify the area. This is the administrative dashboard in our system. We can measure we can select the specific area, and we can find the total number of solar panel connect with the system, and how many solar system generate the solar energy, and the amount of the generation we can individually can identify and measure, and individually switch on and off. We have features to on or off, but and also the old system can disconnect the system with the existing generation of the grid system. This is the testing and result, the experiment and result, the test capability. The hardware validation has the sensor plus or minus 105% error, and relay accuracy is 100% accuracy, and communication and data integrity, and there has the 10s latency, and the GPS plus or minus 2 meter, and system interoperability and full capability, and user interface evaluation has get the positive feedback and high response. When it comes to the experimental result, the key performance of the metrics, we can measure the total power generated from the solar system, and also we can measure the total power consumed in the grid system. When it comes to the conclusion and future works, the conclusion, the system is introduced the smart solar control system that integrate with the IoT and GPS technology and real-time analysis. We can identify the how many solar systems are connected with the how many solar systems are connected with the specific area, and we individually connect and disconnect with the existing generation of the grid system. There's the and Norachol and the water power plant, and when it comes to the future works, they have the we are hope to add the AI based forecasting system for the analyze the specific area to reduce the generation of the grid system with the solar. This is the reference. Thank you.
Okay, right. Thank you very much for the clear presentation. Before we ask the question, I would like to give this opportunity to the audience to ask the question. Do you have any questions to ask? Okay, shall I ask a question? Yeah, so basically according to now in your presentation, you mentioned that the system achieved the sensor accuracy plus or minus 1.5, right? So then maybe can you explain what kind of testing methodology you use in order to maintain the accuracy level of that?
Yeah, we measure the output with the multimeter output. We can test first we construct the circuit, and we get the data, and we test with the multimeter output, the manually tested.
Okay, Right, then there's another one I want to verify, because this is mainly rely on the cloud connectivity and so on. So then maybe how we are going to maybe protect the data and GPS location data, things and that. So what is the mechanism you're going to use for that kind of things?
Yeah, this system is the main author that has the full responsibility for the utility operators. They are the like what CEB and LICO. They has the full authority the monitor the individual solar system, and they are in the recently choose the owners they are not willing to switch off the solar system with the existing solar generation. There is no system in the main control of the CEB system, and then in that system we have the authority. The CEB has the authority to individually turn off, disconnect the system with the exceed generation. Due to the exceed generation of the solar system, this is the unbalance with the solar system and grid system. The previously the Norchola is the breakdown the 3 days. There's the long time to start the restart the Norchola coal power plant. There's the many process.
Okay, thank you for the presentation. I'd like to ask is, you mentioned that your system, you need the internet facility, right, to access. So what is going to happen, sometimes the internet is going on and off. At that time, how you going to keep up with the updated of the solar energy and those things, how you going to rectify the missing parts?
Yeah. I think the solar system, the new friendly solar system has the Wi-Fi router remotely see the how many generate the solar kilowatt hours in the day. But that router can be used the GPS system, and also we can think some power cut, the router doesn't work. But we can use the system to add the include the SIM, the internet connection, like the mobile phone. They has their battery system can add, and like 2 hours they has the battery backup.
Okay, thank you. So one last question. What sort of limitations and the challenges you saw it when you are doing your system?
There are limitations. I think this system is mainly proposed the solar generation below the 20 kilowatt. The system easily control the 20 kilowatt. The many 20 kilowatts, the small solar energy systems are increased, but the above the 20 kilowatts hours we can individually disconnect with the combine with the CEB and LICO, but cannot disconnect the individual below the 20 kilowatts. There are the many solar energy system in the rural areas and above around the country.
Thank you very much.
Thank you so much.
Okay, let me to call upon the next presenter. He's going to present on the maybe the next the paper ID is 108. her presentation title is on knapsack-based daily tolerance resources allocation in the trusted fog edge cloud systems. And over to you to present your presentation.
Good afternoon, everyone. I am here to talk about my paper, our paper on knapsack-based delay-tolerant resource allocation in trusted fog edge cloud systems. My name is Shalini Rajasingham and my co-author is Utpala Premaratna. So, as we all know, in these modern applications, we use fog computing to reduce the latency and to give us more results, more yields with respect to the data that we are trying to process. But when it comes to the, certain applications such as smart parking, traffic control, real-time monitoring systems, we always operate under strict timing. So this paper investigates how delay application can be reliably supported in fog computing environments, and we also propose a multi-stage fog node selection strategy which is based on latency, processing power and bandwidth, following which is applied for delay sensitive resilience based evaluation. And we have also tested this system with respect to communication and computation scenarios, and our results show that even though there are existing in the literature processing power comes to play the vital role, it has to have a balanced strategy. So let me go through the fog edge cloud architecture. We have used the architecture that is based on open fog reference architecture. So it is a hierarchical architecture, as we all know. So we start from the very bottom where the edge nodes generate data with minimal computing capability, and when we go a little bit higher up the hierarchy, we could see that there are cloud nodes which is offering higher processing power with the obvious limitation of having a higher delay. So why we use fog computing is, cloud computing alone, it does not tolerate the high latency even though it has a high processing power. Fog computing, it brings computation closer to the end users, but at the same time this reduces communication delay and supports time critical services. But with respect to processing power, we also have noted that only having processing power is not sufficient, and therefore we have come up with a knapsack based fog environment. So we all know that fog environment consists of multiple distributed and heterogeneous nodes. So in like I explained in the introduction itself, in our delay system sensitive systems, responses are delivered within a time threshold. So there are systems which, when it is beyond a particular time, it is considered to be failure, because it's not about the correctness but it's about the time. So high processing power, meaning giving the correct the answer or the correct output, is not only sufficient but it has to comply with the strict delay requirements as well. So when we have unreliable fog nodes, it may, because of the processing power, give us correct information, but also during disruptions, adverse network condition, there are possibilities of violating the delay constraints. So in literature, there is a conventional resource selection strategies which often prioritizes performance and neglects trust and resilient factors. So this oversight actually does not produce a reliable situation in a practical deployment, because again, like I said, when it comes to delay sensitive systems, time is an important constraint that we have to follow. So why we have resilience is, basic definition is, it maintains acceptable performance under disruption. So disruption can cause due to communication and computation delays. It could be other factors as well, but for our research we have considered the communication and computation only, and this study focuses only on the disruptive tolerance. And also trust. How we have computed trust is, we have taken it's not basically on an authentication factor because it gives us a lot of overhead. Therefore, we have observed the fogs, and based on a behavioral and performance based metrics, we have computed the trust. And the nodes that violate the delay constraints are considered to be less trustworthy. So the parameters used for the fog node evaluation is latency, processing power, bandwidth, and trust. So like I said, trust is considered to be based on the observational, based on how they have performed in the previous behavioral analysis, and also latency, as we know, and then processing power and the bandwidth. So this is a multi-stage knapsack algorithm for fog node selection. So first of all, we have 3 stages. In the first stage, latency is evaluated. We have given a particular threshold, and if it exceeds that particular threshold, then we remove it. If not, we keep that node. We also test it with respect to the processing power and also the bandwidth. If the nodes satisfy latency, processing power, and bandwidth, they are identified as suitable fog nodes, whereas in literature, normally, as long as they have the processing power, it is taken as a suitable requirement. But when it comes to execution, they don't perform very well. So like I said, we have the delay and disruption model. Once we have selected the fog nodes based on the respective selection model, we test it with scenarios that has communication delay and computation delay. So with communication delay, we deliberately created network slowdown, unavailability of increasing, and lack of data availability likewise. So the offloading task from one node to the other introduces additional delay. So as I have mentioned before, this is a knapsack based selection logic where we have applied to a subset of nodes, which again maximizes the reliability. So we selected a bunch of nodes based on the 3 selection criteria, and then we applied to the computation and communication scenarios, and from there the performance was evaluated, and these were the results. So as we can see, though we tested it with trust, there were nodes that did perform very low with respect to score, but with respect to processing power, though they have a linear performance with respect to the score and the processing power, still there were some nodes that was remote. But with respect to balance weightage, you can see that most of the fogs, they have a higher score, and also there are more fog nodes compared to the others. So the conclusion is that this knapsack approach is producing more resource-based fog rather than having the processing power. And in this particular scenario, for delay-sensitive scenario, we have proved that not only processing power but also latency, bandwidth, and also trust approaches are good for fixing scheduled strategies. Thank you.
Okay, any question from audience? Okay, let me ask a question. Now, how does integrate the trust metric into fog node selection improve maybe resilience in delay sensitive applications?
So how we did this, we used a car park simulation,
right?
And based on a fog computing platform, that's how we created the whole simulation. And so we took the capacity to be the latency and the items to be the processing power and the bandwidth, and from there we calculated using the knapsack algorithm as to how we can get this thing. So we so the car park problem was the testing simulation that we used.
Okay. Then the one more question. Then how does the multi-stage knapsack techniques help optimize the fog maybe node selection under delay constraint?
So we used multi-mode selection because if we use the normal, single layer selection, we won't be able to get this much of an accuracy. So that's why we have to use, so that we included the latency, bandwidth, and also the processing power and also trust to get this particular output. If we haven't used multi-selection knapsack algorithm, we won't be able to get this, because traditionally they only in literature they only use the processing power.
Okay, right. Thank you very much.
Question I like to ask, you mentioned that the simulation you done it using the car park. Is there a specific reason you have selected the...
Because with car park we can actually control the actual input, and also we could have taken any other system, but with this we can actually monitor the delay constraint directly. So, and also this is a common simulation they use for fog computing. So we had a lot of parameters that we can compare it with.
Right, okay. So another question I like to ask, is there any possible some other future directions that you like to...
Yes. Yeah. So this is just for testing scenario. So in future we want to test now here though we have used trust, we haven't computed it with respect to a particular threshold. So we would like to emphasize on the trust for the future. So that's when we want to introduce the simulation for maybe for another journal paper.
Right, okay. Thank you very much.
Can you hear me? Can you hear me? Yes, can I share my presentation?
Okay. Okay, right. Only for this. Okay, the paper ID is 68. The presentation is based on the multi-language cognitive and structural complexity analysis and optimization framework. So over to you to present your presentation.
So, can you see my screen?
Yes.
Okay. So, thank you. Good afternoon, everyone. My name is Vishalini Pradap from Slate Nadanjini Jaffna. So, today I am presenting my research title, Multi-Language Cognitive and Structural Complexity Analysis and Optimizational Framework. So the introduction, as our software system grow, they become harder to understand and maintain. We normally use many metrics to measure complexity like cyclomatic complexity, line of code, maintainability index, and cognitive complexity. But these metrics work separately and they given fragmented results. Developers also cannot to get completed picture of maintainability. And also these metrics are not consistent across different language like Java, C or C# or other language. So the key issue I found there is no single unified measure that works across the language give a clear maintainability score using that different language. So in the background study, so different metrics measure different aspect of code. So that a VG, that cyclomatic complexity measures structure, and that lines of code measure size, maintainability index estimate our general maintainability, cognitive metrics measure mental effort, and that CBO, that coupling design measure that design level dependency. So, but none of these metrics work together. They can work as a separate single individual metrics. So this create confusion when evaluating code quality. So in my literature review, so I found some studies. So these previous studies shows some strengths as well as some limitations. So the VG is good for structure, but ignores cognitive difficulty. That lines of code LOC is simple, but size is not equal to complexity. MI is useful, but outdated and ignores some complaints. ICB capture cognitive load, but misses design dependencies. So another tools like CCMT and CCAOT only support partial metrics and mainly Java, not other language. For this, we can see a clear gap. No research provide a unified multi-language maintainability measure. So that's why I proposed a solution. It's called Unified Maintainability Complexity Score System. So we can call as a UMCS. So UMCS combined with 5 important dimensions of code quality. Those are ICB, that means the cognitive complexity, structural complexity, VG, lines of code size, MI maintainability, and CBO coupling between objects. These 5 values are normalized to 0 to 100 scale and then averaged to produce one simple code. Each matrix after that, each matrix is converted to normalized value using this formula, that min mx over tx. Here the mx is raw matrix and tx is the threshold of literature. And finally, after normalization done, after final, we can calculate our UMC score using this equation. This gives one easy to understand maintainability score between 0 to 100. Existing matrix looks at only one part of the problem. Some measured structure, some measure size, some measures cognitive load, some handle maintainability only. But none of these combine all these factors together, and they also don't work consistently across different programming languages. So what make our concept new is that UMCS bring all 5 important dimensions into one unified scope using a language natural IR. This means the same logistic written in Java, C, C# produce a consistent, comparable results. So developers or managers can easily get the clear and reliable maintainability score. So in the research, I follow this 5-step methodology. First, select 5 core metrics. Second, normalize them into the same scale. Third, design a language IR. IR means intermediate representation tool. Fourth, extract metrics from Java, C, and C+ program. Compute and compare to the UMC value. So the IR model is a very important here because it makes the analysis consistent across all other languages, that Java, C, and C++. So what is this intermediate representation IR here? So here we use abstract syntax tree of Java, C, and C++. So here we have multiple languages, that means Java, C#, and C. Then this code transfer to this abstract syntax tree, then it transfer to the IR. So this IR capture decisions, loops, method operations, recursions, and coupling links. Then this ensure that the same logic in different language produce a comparable matrix value. So that's why here this IR is a very important part. So let's see some example for how this is work. So here I use some sample example factorial function was implemented using a Java, all language, Java, C Sharp, and C. All three versions have the same logic and therefore produces similar IR structure. For our example, the extracted raw matrix values are almost identical. So the results, so here you can clearly see the matrix extended from all three languages, Java, C, and C Sharp, all are same level. This shows the IR model successfully remove all the language barrier, language specific difference, and allow fair comparison with these different languages. So when we normalize these values into our UMC, so Java got 9.3 and C got 10.1, C Sharp got 9.7. So all fall into excellent maintainability range. This proves that UMCS gives stable and predictable results across the language. So all a small program might have low LOC, but still be hard to understand. So we are considering that UMC give clear insight than using other separate metrics because all the small program might have a low. But cyclometric complexity cannot measure cognitive effort. MI ignores modern construct and design issues. But our UMCS combine all 5 dimensions into one meaningful scope. So in the conclusion, UMCS provide a holistic, easy to understand maintainability score. It's overcome the fragmentation of traditional metrics. That IR model ensure language natural analysis. Then UMCS shows consistent and reliable results across the different language like Java, C, and C Sharp. So this framework is useful for software evaluation and teaching and future tool. So this research closes an important gap in a multi-language software complexity measure. That's why I introduced this UMCS method. So finally, thank you all. I would like to sincerely thank for the committee for this opportunity for online presentation. If any questions, you can ask.
Okay, right. Thank you very much for your clear presentation. Do you have any question from the audience?
Thank you for the presentation. I just have one question. So with the UMCS score that you did, you compared Java, C Sharp, and I don't remember the other language. But what would be the result that is expected if you compare with a language like Python, where the native script would be much simpler than an equivalent program written in C Sharp or Java? So what would be the expected UMCS score as per your system for a language like Python?
Okay, so yeah, I can't clearly hear that question, but I guess the question how we can implement the Python into here, is it, sir?
Sorry, yeah. So what I'm asking is, when we compare Java, C Sharp code, they would be
Yeah, so my question is, when we have a programming language like Python, where the script itself, you can hear me, right?
Yes, I can hear clearly, yeah.
So if we take a programming language like Python, where the script itself is very simpler, with your score, how would the score look like? Because here Java, C Sharp, anyways, they look like the same when you consider lines of code or something like that. So Python, what would the score look like in the system? That's what I'm asking.
So Yeah, actually, I done my research for these Java and C Sharp. I didn't think about that Python, but we can include that Python because we have that IR, that intermediate representation, even Python or PHP, everything. So loop or like every structural is same. So first we can convert that IR, then we can go for this method, UMCS method.
Okay, any other question from the audience? Okay, right. Let me ask a question. Can you hear me?
Yes, sir.
Okay, right. So what practical challenges might arise when selecting the threshold values for normalizing the unified the maintainability complexity score? And how could these challenges affect accuracy of the final score?
So you're asking how the challenges we have when we select this one.
Yes.
Is it, sir?
Yes.
So actually, why I choose these 5 metrics into my thing, because these are the common things. That means the common metrics. So they are almost influence factors in maintainability, and no existing works have these kind of these ICD, VGLOC, MI, and CBO. So we can easily influence to that current system. That's why I choose these 5 things.
Okay, so one more question. This is based on the papers. Now, the paper state that the unified maintainability complexity score that shows the better association with the defect density and the chain, the pronouns. How does the unified metric improve the predictability compared into the individual metrics and so on? So no. So what is the answer for that one? Shall I repeat the question again?
Yes, sir.
Yeah. So now according to the paper, right, that it says the better association with defect the density and the change the pronouns. How does the unified metric improve predictability, right?
Yes.
And compare the individual metrics.
Yes.
Yeah, that's the question.
So,
now the question, how does the unified metric improve? That is the part.
These unified metrics include to our real world things?
Yeah.
Okay. So we can integrate this UMC with that CI/CD pipeline, or we can plug in. We can use as a plugin to some IDE tool to give a real maintainability. Is that answer to your question, sir?
Okay. Right. Fine.
Right. I like to ask a question. You mentioned that this optimization, right? So who actually can be benefited? For example, so programmers who are learning, or the one who are trying to check the optimization of the code segments, who can benefit your output of your research? Mainly the ones.
Yeah, mostly I focus to programmers. Programmers can focus here because they can't check every time. So they can use this one easily. They can check.
Right. So when it comes for this optimization, so what are the parameters? How this optimization will be calculated?
That we can get that 5 metrics values, then we can calculate that average. Before that average, we are convert into all that value into 0 to 100 score. After that, we convert.
So are you going to consider sometimes the program can be like from problem to problem, the way you are programming will be differ, right? So are you going to concern about the subject, the problem that you are trying to resolve from the code during the optimization part?
So is that question is, ma'am, that how we can get that these metrics from that real world program?
Yes. For the problem, how you going to calculate the correct optimization based on the problem that the program is trying to resolve?
Okay, so how we can get these values from that real world?
Yes, real world problems.
Yes, we can for the IDE or I plan to do in that my next research. So I plan to do some AI integration with this UMCS so that AI can get that thing from that code and it will be integrated with this UMCS. That's my future plan.
Okay, thank you very much.
Okay, right. Thank you very much for your presentation. Okay, next paper ID is 148. Sounds in there. Just wait, we are checking. Could you please start?
Okay, good afternoon all. Today I am here to present our research work titled on parallel recursive decomposition for maximal click enumeration on multi-core system. First, we will start with the core concept. The click in a graph is a subset of vertices in a graph where each vertices are connected with all other vertices. And the maximal click that cannot be extended by adding any other vertices. And these NC enumeration has many real-world applications, such as in social networks. We can use it for detecting the communities and for the identifying the complex protein complexes in bioinformatics and to identify the attack surface analysis in the cybersecurity. And in the previous works, they are using the standard algorithms for you finding these maximum click enumerations is Bern-Kerbosch algorithm and its pivot variant. However, the sequential implementation shows the serious limitations in the execution time. The execution time exponentially increases with the large and the dense graphs. At the same time, the modern computers are equipped with the multi-core systems. And in the previous works, the researchers mainly focused on the GPU implementation and the distributed system kind of solutions, but it needs special hardwares and the expertise. So our motivation is to design the practical, accessible parallelization for this NCE problem using the standard multi-core CPUs with the OpenMP. So based on our motivation, our main aim is to design efficient parallel NCE algorithm for shared memory system. So the key objectives of our works are the parallelizing the BK algorithm and the pivot BK algorithms using OpenMP and employing recursive decomposition and vertex level task parallelism in our algorithms and ensuring the correctness That means avoiding the duplicate clicks and the race conditions, and maintaining the load balancing with the static and dynamic scheduling, and finally evaluating the scalability and speed up on the synthetics graphs. So this is the simple blueprint of our parallel algorithm design. So A shows a real world graph with the 5 vertices, and sequential approach of Bern-Kerboch algorithm, how we can find the maximum clicks. And the C shows our parallel idea. We plan to divide each sub click calculation to each thread. And so our core idea is recursive decomposition of the search space. So we use the parallel strategies like partitioning the top level candidate vertices across threads, and make sure that each thread explores an independent subtree from a unique start vertex. And the key techniques we used here is pruning the initial states that will prevent duplicate enumeration, and maintaining the thread local click counters that will avoid the global synchronization overhead, and finally combining these local clicks as a global count safely. And we use the scheduling strategies, static and dynamic scheduling strategies. The static means at the initial point, the vertices will be evenly partitioned to the threads. But in the dynamic scheduling, at the runtime, based on their workload, the vertices will be shared among the threads. And we incorporate the pivoting, so that pivoting will reduce the recursive calls per threads. So our main focus of our implementation is minimizing the synchronization and maximizing the independent work for each thread. And as an experimental setup, we use the graphs as a synthetic graphs that will generated from the Erdos Sreni model to 5000 vertices, and the densities varies from 0.1 to 0.5. And the hardware system, we use the 16-core Intel i7 CPU with 16 GB RAM, and the implementation was done with the C language and the OpenMP. And at last, we tested our BK algorithm and the BK pivot algorithm with static and dynamic scheduling by changing the threads as 2, 4, 8, 12, and 16, and we measured the execution time. So as we expected, with the graph size and the density, we observed the increased execution time. But the parallel versions are consistently faster than the serial one. And our main finding from this experiment is the BK pivot with the dynamic scheduling algorithm achieves the 11.2 times speed up on 16 cores. And the scalability that affect with the core count, so up to 12 to 16, we can see the efficient performance. And here we can see the speed up changes with the sparse range for the parallel BK algorithm and the parallel dynamic scheduling. So it shows that a parallel pivot algorithm with a dynamic scheduling works best, because that pivoting reduces the thread work per thread work, and the dynamic scheduling compensates for the irregular search space. And we observed some scalability limitation in the low thread counts like 2 and 4, and also the dynamic scheduling also shows some minor overheads in some cases. So the conclusion, we successfully implemented the parallelization of BK and the BK pivot algorithms using the OpenMP, and the recursive decomposition and the dynamic schedulings enable the scalable performance, and the 11 times speed up on 16 scores demonstrate the practical efficiency of our work. And we can recommend to use the parallel BK pivot with the dynamic scheduling algorithm for real-world NCE problem. In our future work, we plan to incorporate the hybrid CPU GPU approaches with our work, and expanding our work by adapting the dynamic graph strings. Thank you.
Okay, right. Thank you very much for your clear presentation. Do you have any question from the audience? Okay, let me ask a question. Can you hear me?
Yes, sir.
Okay, so now how does the BK pivot algorithm perform better than the basic BK algorithm in parallel?
So BK pivot means we will choose a pivot vertices first, and we will find the clicks for that vertices first, and after that we will calculate that the clicks for others. So when we are parallelizing these, that finding the pivot is also will be parallelized. So the recursive decomposition will be reduced.
Okay, right. So the one more question. Sorry, what are the potential limitations of the OpenMP based parallel approach?
Yes, the main thing is the overhead. So when we enabling the global synchronization, so the communication, the thread communication is the main issue in the OpenMP.
Okay, right. Thank you very much.
Okay, thank you for the presentation. Only one question I like to ask. From your algorithm, like let's assume when number of nodes and the complexity of the relationship between the nodes are getting heavier and heavier, how your model is going to be executed to see whether it is going to perform well or not. So what sort of testing scenarios you have done it to see the difference of when it comes for the nodes and the complexity of the relationship between the nodes? How we have done the testing to see the speed, how it has been increased, your algorithm?
Sorry, miss, I couldn't get you.
What I'm asking is, in your algorithm, you are trying to get this correlation of the speed, right? So based on the different nodes and how the nodes are related with each other with the network. So my question is, when the number of nodes are increased and when the nodes are connected and the relationship are getting heavier and heavier, how is going to affect with your algorithm the speed and the final result?
Yeah, if the sparsity increased or the size of the graph increased, so that will cause the communication overhead here. So that will affect the algorithm.
What sort of scenarios, how many nodes and what sort of a complexity did you tried your algorithm?
Sorry, miss?
What is the complexity and what sort of a node structure did you tried your algorithm is working? In the results discussion, you mentioned about number of nodes and I
Sorry,
saw
I
one
couldn't
result.
get it.
Sorry? I saw one slide consists of number of nodes. What is the complexity that you have checked?
Is this?
No, go to the next slide. Previous slide, previous one. Results. Yes, number of nodes is 100 to maximum is 5,000.
Yes, yeah.
Okay, so more than that you haven't tried it, right? So that is the limit that you have tried your results. Is that so? Okay, yeah, thank you very much. No, it's okay. Do you have anything to add? Okay, thank you very much.
Thank you.
මම දාපු ලකුණු ටික මේක කොහොමද ගන්න වෙන්න ඕන වෙනසක් තියෙනවද ලොකු යාට වැඩි වෙනවද ඒක ටෙක්නිකල් සයින් එක ටිකක් වෙන්න මට හිතුණා ටෙක්නිකල් සයින් එක හොඳයි
As we come to the end of the insightful presentations, now it's time to give the certifications for the presenters. For that, I cordially invite Dr. Samantha Mathur Arachi to give the certificate for paper ID 25 titled Real-Time Control and Monitoring Decentralized Solar Energy Systems Using IoT and GPS Integration. Author V.O. Mahendra. Sir. Now I cordially invite Dr. Upeksha Ganegoda to give the certificate for paper ID 108 titled Knapsack Based Delay Tolerant Resource Allocations in Trusted Fog Edge Cloud System. Author S. Rajasingham. Thank you, Madam. Certificates for online presenters will be sent by post. As we come to the conclusion of this session, I want to extend my heartfelt gratitude to all speakers, participants, and especially our esteemed session chairs, Dr. Samantha Mathur Arachi and Dr. Upeksha Ganegoda, for their valuable guidance and insights. As a gesture of our appreciation, please accept this token of gratitude as a small acknowledgement for the immense value you have added today. Thank you once again for your time, effort, and expertise. I cordially invite Dr. R.C. Sharma to give away the token of appreciation for Dr. Samantha Mathur Arachi and Dr. Upeksha Ganegoda. Thank you, Madam. That brings us to the end of the session. Thank you everyone.
I apologize for the delay because of some of the issues with my computer. Right, let's move on to see what I'll be sharing with all this evening. First, we'll take a look at what computational intelligence is all about. Okay, I will cover some discussion on the architecture as well as the algorithm. And then the second part of the presentation is basically focused on the real-world application of computational intelligence. Right. From data to decision, okay, basically this is a very classical pyramid published in 1986. Okay, what we are trying to do is to combine machine intelligence from the bottom of the pyramid, where machines are good in processing data and extracting information from the data, while humans are good at the top of the pyramid, where we can make decisions. Okay, and then when we make decisions, we are basically using our judgments. So what we are trying to do is to combine human intelligence at the top, or human wisdom, and then machine intelligence at the bottom, and then we design some algorithm that covers the so-called both advantages of humans and machine together. And ultimately, what we are trying to do is to design some algorithm, human-centric algorithm that could process structured information and deduce insight for supporting some of the AI-related kind of applications. So that is basically the idea of this so-called from data to decision. Right, what is computational intelligence? Okay, computational intelligence is a term coined by Professor Jim Bester in 1994. Okay, basically it defines that a system is computationally intelligent when it has this component. First is it deals with data. And then how to deal with data basically is to use pattern recognition technologies or techniques. And then by using pattern recognition models for data analytics, then the system would also have to demonstrate computational adaptability, computational fault tolerance as well, in order to park under the so-called AI sense. So in short, basically CI to me is an umbrella, it is a branch under the umbrella of AI. Right, David Fogel in 1995 further defined CI as the technology of neural, fuzzy, and evolutionary computation. So all these things is pretty much aligned to the work that myself and my students has been doing for the past 20 over years. So basically what we are trying to do is to design a computational method that can adapt solutions to new problems and do not rely on explicit human knowledge. Right, what are the key CI models? Okay, traditionally, we have artificial neural network, and now it is deep learning. And then we also have a fuzzy system, evolutionary agent, and etc. And more importantly, my research focused more on the hybrid CI models, where we combine neural and fuzzy together, or neural and evolutionary together. The idea is to each of these CI models has their advantages and disadvantages. So by designing hybrid models, we are trying to leverage the advantages of one particular CI model, for example, neural network, and then try to also mitigate its shortcomings. So that's why we combine CI models together to exploit their advantages, and at the same time trying to minimize their limitations. Right. Neural network or deep learning now is basically a model that emulates the low-level information processing of the brain. So what is artificial neural network or neural computing is good at? Basically is data processing. Okay, so how about fuzzy? Fuzzy is basically a model that deals with linguistic vagueness, okay, with a high level human reasoning, control, and decision making capabilities. For example, if we are saying that, hey, I'm cold, So what is the definition of cold? And hot, what is the definition of hot? So instead of a crit kind of division between, for example, in this particular case, warm and hot, so we have a fuzzy membership function, okay, to demonstrate the changes in terms of different opinions from human, okay, in interpreting what is cold, what is hot. So that is basically fuzzy provides a linguistic variable kind of fuzzy membership function to capture human intelligence. Evolutionary computing is another big category, which basically is good for search and optimization. It probably started with the earlier notion of a genetic algorithm, but nowadays there are various sorts of models in terms of evolutionary algorithm. For example, ant, particle swarm, and etc. So the focus of my research is mainly on the stability plasticity dilemma. Okay, what does this dilemma tell us is if we were to design a machine learning system, how do we make sure that the system is able to learn, okay, previously information without corruption, meaning that it's stable. And then at the same time, it can absorb new information online that is basically plastic. So this is basically a classical stability plasticity dilemma. So one of the methods to tackle this active resonance theory. So this is some of the models that we have been working on. Basically, it's a hybrid neural fuzzy model, from a fuzzy ArcMap, fuzzy MIMAX algorithm. So the key is basically how to take the advantages of fuzzy ArcMap and fuzzy MIMAX in terms of autonomous learning, meaning that online learning without retraining, as well as through extraction. How do we extract information from a learned neural network or deep learning models and then explain to the user? So basically, it's an explainable AI, in the current terminology. So this is a bit of an architectural design of the ARC model. So basically, it covers two unsupervised module of ARC A and ARC B, and then it links. Both input and outputs are linked by the map field. And then in terms of how it process information, so basically the architecture learns through the so-called winner take all. So when an input is propagated to the so-called input layer, it is sent to the output layer, and then a TJ function, basically it's a similarity function, is calculated based on certain fuzzy operation, a combination of fuzzy operation. And then the winner take all will take competition will take place, and then the winner will basically reproduce the weights to the input layer, and then this is controlled by the recognition, another equation. So basically, there are two levels of matching, bottom up as well as top down. So that is the architecture of ARC that has a slight difference from some of the models currently in the literature. So how does ARC learn? Basically learn in terms of hyper rectangular kind of clusters. So by doing so, what we are trying to do is to inject certain probabilistic information into the ARC learning module. So that instead of just deterministic saying that this is class 1, this is class 2 in terms of data classification, so we have the so-called Bayesian probability so that it can produce a probabilistic output that this is 70% of class 1 and 30% of class 2, instead of just saying that class 1 and class 2. So basically we move from a deterministic prediction to probabilistic prediction. So this is some of the research work that we have done to incorporate the Bayesian theory into the parameter estimations. So we have two key key parameter to estimate in injecting Gaussian kernel into the system. First is the centroid or the center of the and then the of the Gaussian kernel, and then the second is basically the width. So in terms of the width, basically we use the average gradient descent over gradient distance over k number of kernels. So this is a very important parameter that we need to estimate accurately. if we see that, if we are kernel of estimation, okay, the width is so what you call tight, then you'll be very spiky kind of estimation, probabilistic estimation. So if we have a good so-called estimation of the width, you can see that this is all online learning. Okay, the first one is on the top left is 100 samples, and then the second one on the top right is 101 and 200, and then the bottom one is basically after it learns 3,000 sample. This is basically what we are saying, that it learns sample by sample in an online learning basis. So again, okay, if we set an inappropriate parameter of the width, then the estimation will be poor. So this is another demonstration of the underlying patterns learned by the additive resonance theory. So if we only have learn 100 samples, now the underlying pattern might be noisy, and after 10,000, you can see that it learns better and better when more and more data samples are presented for learning. So again, we analyze the performance in terms of noisy data. So this is a circle in the square or noisy circle in the square kind of evaluation. And then we can see that the modified version of the Gaussian kernel that we incorporated into the ART actually presents better results. So this is a demonstration of the so-called non-stationary environment. Okay, we can see that, if we were to change the data statistics over every 5,000, would the, ART-based model be able to track the so-called data streaming or evolving data streaming kind of a task? So by, injecting certain modification into the ART, you can see that the ART model is able to track the Bayesian optimum probability under data streaming environments. Right. So another way to improve the performance is basically, and what we are doing is basically based on this so-called agent-based modeling. So we are combining different models. For example, one agent is good at image processing, another agent is good at signal processing, another agent is good at text processing. So we combine their capabilities together to produce an output based on these so-called trust negotiation and communication reasoning models. Right. So this is the second part of my presentation, where I'll showcase some of the applications of this additive resonance theory that we have been working together with some collaborators. The first is the medical diagnosis. So the problem here is to conduct prognosis of discharge conditions of acute stroke patients. So what we are trying to do is to predict the patient, a stroke patient, after this being discharged from the hospital, whether he or she will be fine or he or she will develop serious disability. So what we are doing is to capture information from the patient, obvious information like their age, their sex, whether they are alcohol consumption, whether they are smoker, and etc. And then based on this, okay, we put it into the additive resonance theory, and then the system or the model will produce a prediction, okay, of whether this stroke patient is having difficulties when it is being discharged. So that is basically the results. Okay, we can see that this the graph showing that, okay, is online learning, but more importantly is actually the rules. Okay, the so-called explainable rules, okay, extracted, okay, from the additive resonance theory. And then the rules say if age is high and the let's say underlying hypertension is from medium and high, so all these are membership function, then the patient, okay, being discharged with disability, and then the confidence factor of 0.8. This is deduced from the Bayesian probabilities. So this is a small program developed to show that how do we implement this on a web-based system. So first of all, okay, we have the patient data coming in, then we do the so-called online learning, etc. So when a new patient comes in, we punch in as many information items as possible, And then the system will give a prediction to say that, hey, this is a good patient or this is a, at-risk patient. And more importantly, the system is a predictor as a, so this would basically produce certain so-called information or insight for the users. And then in this case, the users are basically medical practitioners. So the selling point of this system is basically to provide justification or reasoning to the users. So moving on from the medical diagnosis, so what we next apply the system to is basically for diagnosis. The idea is the same. Instead of taking information from patients like the age, whether they're smoker, we take basically sensor data from various points like temperature sensor data and pressure sensor data at point A and point B. And then from there, okay, we again use the additive resonance theory as the learning model behind, and then we extract the rules to explain. Okay, for this case, is the power generation plant, and whether the heat transfer process in the power generation plant is efficient or not efficient due to a blockage in the piping of the system. So this is a small program demonstrating the usage of the system. So what we can do is the system will produce, what you call certain rules after the learning process. So when the new data comes in, the pattern matching models behind the scene will take place, and then you trigger the most similar patterns. And then once an alarm is sound, the user, in this case is the maintenance engineer, can go and take a look what is the sensor reading for various points, and more importantly is what is the rules trigger this particular prediction. So again, it provides another layer of justification for users to see whether the prediction from the models, AI models or CI model is reasonable or not. And then this is another one of the application where this is we try to do predictive maintenance of the train in Sydney. So what we are trying to do is to capture sensor data from various points, and then we combine business rules from humans as well as rules extracted from data. And then these two sources of information would be supply to the machine learning models behind the scene for it to learn the patterns. And then from here, we also extract the rules. Again, if you see the demonstration for the past three application, rule extraction or justification of prediction is one of the key focus of our research. So this is a small video demonstrating the systems.
We're getting 30,000 scores every 10 minutes. These are trained brains. Turning that data into an insight, that's really the gold dust.
We've built a platform with Microsoft called TrainDNA. We're using Microsoft AI to anticipate how much maintenance we're going to do and how much downtime is needed.
TrainDNA is going to turn that information that we're collecting into something that we can use to improve reliability of trains.
Right. So basically, that's some of the works that we have been doing. And then just to move forward, okay, now we are talking about Industry 4.0. Then how about the next industrial revolution? So Industry 5.0, how would that look like? Basically, the some of the publication highlights that the Industry 5.0 perhaps is an era of human-machine synergy. That's why we're trying to design the system that combines human intelligence and machine intelligence together. And then instead of, in addition to Industry 4.0, we also have this so-called Society for 5.0 from Japanese government. Okay, the Japanese government look into the future of the society, and then come up with this concept of promoting human-centric society with AI. That would basically set the scene for us to move into not just Industry 5.0, but also Society 5.0. I think with that, thank you, and thank you very much for your attention. Thank you. I'll stop sharing.